Hey, what's up guys? Welcome back to another video. In this video, we're going to dive into Minestom. So this is going to be a new series that I'm starting. It could be a small series, it could be larger depending on how many people like it and how interested people are. But yeah, we're going to explore something called Minestom, which was requested by some of you guys. I'll have a link for this website in the description below so you can check it out yourself. It's got a lot of important information. But yeah, it's a lightweight open source Minecraft server built from the ground up. So what that means is that it's not Bucket, it's not Spigot, it's not Paper, it's not Fabric or anything like that. It's literally just a Minecraft server that has nothing. Everything has been ripped out and it's very bare bones, and you have a blank slate to create all the custom functionality that you want. This is great for custom servers that have a lot of custom functionality, or even minigame servers that have a specific purpose. Let's just go through some of the points here. So it's lightweight because, like I said, it ripped out all of the existing vanilla features of Minecraft, and you have to implement that yourself or not at all. So it's very fast. Whenever you start up a Minestom server, it's like literally within seconds. It's absolutely insane. So it comes with minimal functionality, which allows for a more efficient and lightweight server that can be easily extended. There's a community of developers that's growing. That's awesome. It's written in modern Java, which is even more awesome. It's got high performance for efficiency. It's multi-threaded, which is huge because traditional Minecraft servers, like it says, like Bucket and Spigot, are not multi-threaded. You can do multitasking and threading, sort of, but it's just not really meant for those types of servers. And this has built-in out-of-the-box support for that, which is amazing. And then the final point, it says no legacy NMS. So with Minestom, net.minecraft.server is a thing of the past. The protocol is fully implemented and does not obfuscate any code, creating a faster and more enjoyable experience. Because everything is so bare bones, you have a lot of freedom to do a lot of cool stuff that is not possible with other server implementations. And then of course there's the performance aspect that we talked about before. But like everything, there's pros and cons, right? So the pros of this would be that it's very customizable. It's very efficient. It can be fast to start up. You can directly debug it and run it within your IDE, which is awesome. But the cons of this is that it's hard to get started because everything is, again, bare bones. I'm going to repeat that so many times, but it's bare bones. So it has nothing, almost nothing for you to start with. You have to create the server yourself. You have to create the world yourself. You have to even add the lighting system yourself with code. It's easy, but you still have to do it. There's no events that are already implemented. So, picking up items, dropping items, breaking blocks. You can break a block, but nothing drops from that. Like almost everything is just unimplemented. So you have to do that yourself. So that could definitely be a con if you just want a normal, vanilla server that you can extend. And yeah, that's kind of just the main con. The downside that comes to mind for me is that it's just so hard to, get started kind of. Especially if you're new to this, and also you just have to add a bunch of stuff that's not there that you might expect to be there or want to be there. And then, the community is definitely smaller because it's not been around as long as, Bucket, for example. But just looking at the pros and cons and looking at the pros, there's a lot of pros here. There's a lot of benefits to using Minestom, and it's really cool, man. It's just really cool. So in this video, I'm going to show you guys how to create your very first Minestom server from the ground up. I figured out a lot of this on stream with you guys, to help me out, and thank you so much for doing that. A lot of this is relying also on the wiki, so just make sure you check this out as well. It has a lot of really helpful information on their wiki to set up your first server, the dependencies, all the different aspects of a server. Really, really cool stuff. So make sure to check that out. Link in the description below. It's got Java docs as well. It's got the third-party libraries for stuff, if you want to add like fluid systems, slime world format loader, a bunch of cool stuff. So make sure to check that out. But yeah, hopefully you guys are excited to dive into this like I am. The only prerequisites that you need to be able to, watch this series is hopefully Java. You need to know Java, at least the fundamentals of Java, how to create variables and control flow and classes, object-oriented programming, basic data structures like lists and maps and stuff like that. And then you should be good to go from there. You don't have to know anything about Bucket or Spigot, although I expect a lot of you guys will know what that is already. But yeah, that's all I got. Let's get started. Alright, so the first thing I'm going to do is show you guys how to create a new project for a Minestom server. We're going to be using Java, of course, so the most popular IDE for that is IntelliJ IDEA. Hopefully you know what that is, but if you don't know what it is, go ahead and install it. And then once you create a new project, it should take you to this screen here to choose what type of project. We just want to choose a regular Java project. And now we want to set the name. So the name could be anything. I'm going to call mine My First Server. And then now you need to choose a location for that project where it's going to live. So choose a safe location on your computer where you know it's always going to be. And then what it will do is create a subfolder within that folder for that project to live inside of. You can have it create a Git repository if you want to. That's not really necessary unless you plan on storing it in GitHub. You can always add that later if you want to. For the build system, make sure you set it to Gradle. That's what I recommend for this. You can use Maven if you want to, but Gradle is my recommendation because that's what the documentation uses. At the time of recording, the documentation also recommends having at least Java 21, so make sure you have Java 21 selected. If you don't have it, you can download it yourself, on Oracle. Just, search up Java JDK 21 or just whatever the latest is, or you can download it through IntelliJ. They make it really easy nowadays, so you could do either option. Just make sure you have at least 21, like I said. Now for the Gradle DSL, it doesn't matter which one you choose. You can do Kotlin or Groovy. I'm going to leave it on Kotlin. And I'm going to leave add sample code checked because it's always helpful to have sample code, all right? And that's pretty much it. So once you have all that selected and set up, go ahead and click create. And now it's going to generate all the sample code for your project and all the dependencies and all that fun stuff. So give it a second to do all that. Okay, it's already done for me, so let's go and check it out. So what we've got here, the most important part is our main.java class here. So we can go to main, open the Java subfolder, and then me.codysimpson's the package, and then main. So just like any Java program, this is going to be the entry point of your server. So the main method here, we can go ahead and run it if we want to. So just do this, click run main, and now we'll run our Minecraft server. And we don't have anything set up for Minestom, so it'll just print out hello world. So just a very basic Java program. Pretty much all these other files you can ignore for the most part. The other important one is the build.gradle.kts file. This is where you'll set up your repositories for your project for Gradle and also your dependencies. So that's the next thing that we're going to do. We're going to head to the Minestom documentation and then go to dependencies. And this is where it tells you what to put for that Gradle file, okay? So first of all, make sure you choose either Groovy or Kotlin, depending on which one you chose when setting up the project. I chose Kotlin, so I'm going to select those. And now just make sure for repositories you have Maven Central. We already have that. If we take a look here, we have Maven Central already, so that's all good to go. And then for dependencies, we want to copy this part here. This is the actual Minestom dependency, and then we could just add it right after these two, okay? We don't actually plan on doing any testing, any unit testing at all. You could pretty much just ignore these or remove them. I'm just going to leave it because I added it there. I don't really see a problem with that, just for this very basic project that we're doing here. So once you have changed your Gradle file in any capacity, make sure you click the button here at the top right. This will just reload everything and re-import any new dependencies or anything like that, okay? And that's it. So that's how you can create the project and go ahead and install the dependencies for the project. Now let's take a look at how we can actually create a server and run it. So if you come from my other series on bucket and spigot development, this is going to be way different. It's going to have similarities, of course, because there's things in Minecraft that are similar across, any framework, but this is very different. So usually with bucket and spigot, right, we're making a plugin that is going to run on a bucket server or a spigot server, right? And we don't really have to worry about the server aspect of things. That's already handled for us. With Minestom, though, everything is bare bones. You have to not only code any quote-unquote plugin functionality, but you have to also code the server from the ground up. So we have to actually instantiate the server, create the server, configure the world that's loaded for the server, literally every aspect of it. So we're not just creating some regular, bucket plugin, for example. We're actually creating the server itself and then extending functionality onto it to make it a little more advanced, okay? So like I said before, this does not even have a lot of the vanilla functionality that you would expect with just any Minecraft server, like Bucket or even just a vanilla Minecraft server. It doesn't have almost any of that. All you have is the world that you generate, and you have to specify that yourself, and everything else is up to you from there, okay? So with that said, that's a little bit of like a warning, I guess, but I just don't want you to have a misunderstanding on what is about to happen here. So let's get started. So the first thing that we want to do is initialize the server. So we're literally going to create the Minecraft server. Minecraft server is equal to Minecraft server.init. So that's all we have to do to create the Minecraft server. And now we want to create the instance. And an instance in Minestom is the world, okay? If you ever see the word instance, just think of world, all right? Just a regular Minecraft world, pretty much. We'll come back to that in a second, but after we create the instance, we want to also start the server. So we're going to do server.start, and now we can specify the address, the IP address, and the port that the server is going to live on. So we're going to do 000, which is going to be localhost, so just your computer's IP pretty much, and then 25565, which is the default port for Minecraft. So if you want to connect to the server, you just type localhost for the direct IP address, and you should be able to connect, all right? So this code right here will literally just create a Minecraft server with nothing at all in it, okay? So it's going to be an empty shell of a Minecraft server, not even a world. So usually when you create a vanilla Minecraft server using the normal, way of doing things, it creates the world automatically for you, just a default world called world. But for Minestom, there is no world. There's literally nothing, like I said. So that's why we have to create the instance, okay? So let's go ahead and do that. So to create the instance, we're going to need an instance manager. So instance manager is equal to Minecraft server dot get instance manager. So on Minecraft server, you can see that there's a lot of different things that we can access, which will be useful for the future, like get server, get team manager, is started, is stopping, pretty much anything about the server itself. But you got block managers, you have all these different types of managers for doing different things. The schedule manager is going to be important, the command manager. So yeah, that's an important class that you can work with. But now that we have the instance manager, we can go ahead and get an instance or create an instance by doing instance container. Instance container is equal to instance manager.create instance container. So what this essentially will do is create the Minecraft world for you, because like I said before, the instance is the world. And just by default, if you don't provide anything to it, if you want to, you could provide some other information like the dimension type, a chunk loader. If you don't provide anything to it, you'll just get a regular void world with literally nothing inside of it, okay? So that's the next step. We want to basically generate the world. Basically, we want to tell it how to generate the world, in other words. So we're going to do instance container dot set generator. And so inside of here, you can set the generator that will be used when generating the world. So unit, let's open that up. And so now we're going to do unit dot modifier dot fill height. We're going to do 0 to 40. And then we're going to do block.grass block. So this is taken directly from their documentation, just to generate a regular grass flat world so that we can start playing with. Generation can get a little advanced and tricky, so I'm going to make a separate video on generation so we can dive a little more deeply into it, okay? This is the basic code for generating just a flat world, okay? Because Minestom is so bare bones, there is no vanilla Minecraft world. You can't really generate a survival world, as far as I'm aware at least. There is no like built-in way to do that. I could be wrong about that. Something else that you could do though is have one that's already generated, maybe locally or something like that, on your computer, on your single player world, and you could load that into this server if you want to. But yeah, so now that we have the server created, and we're going to go ahead and create an instance so that we have a world to actually work with. We're telling it how to generate that world. We just want a regular grass flat world, and then we're starting the server. You can run this program now and start the server if you want to, but we don't have a way to join it because we need to essentially hook into the async player configuration event using a listener and tell it where to spawn players who join the server. So not even player spawning is implemented in Minestom. So that's something that we have to do. So let's go ahead and do that. So we're going to add an event handler to handle player spawning. All right. So the way that we're going to do that is by doing global event handler. Global event handler is equal to Minecraft server dot get global event handler. And then now we want to do global event handler dot add listener. And now first we want to specify the event that we're trying to listen to. So we're going to do async player configuration event dot class. There we go. And then now you do a lambda. So you could just do control space to autocomplete that if you want to make it easier for you. Let's just go ahead and rename this to event. And I'll dive deeper into event handling in a future video, of course. But what's going to happen inside of this little block here is that whenever this event occurs, we're going to listen to that. So any code inside of this block will be triggered essentially. So we're going to go ahead and do final player. This is code taken from the wiki, but it's very helpful. Event.getPlayer, import player from Minestom. And then now we can do event.set spawning instance. And that's going to take in an instance as the parameter, which again is just the world. So we want to do instance container, the world that we created. So that's going to be the default world that players spawn into. And now we could do player.set respawn point. And now we want to provide a position. So a POS is just a position, XYZ. So we can do 0, 42, and 0, which will just put them on top of the flat world that we've generated. And that's it. So I know that's a lot. This is probably a little overwhelming if you've never done anything like this before, but the more you work with stuff like this, the more you'll get used to it. And of course, you have all the code in the description below. I'll have a link for it so you can check it out. All right, so that's all we need to actually get started. So we're creating the server. We're creating the instance using the instance manager, which is going to represent our world. We're telling it how to generate the world, just a basic flat world that's 40 blocks high using grass blocks. We're using the global event handler to listen to the async player configuration event, which is going to be called when the player joins the server. And what it's going to do is set the spawning instance for the event, meaning that it's going to spawn them in that world, in that instance, and then it's going to get the player and then set the respawn point to a specific coordinate in that instance, okay? And then finally, we're actually starting the server using server.start. This represents localhost or our local IP, and then we're using port 25565, which is the default Minecraft port. So now we can actually do the fun part, which is testing it out. And this part is so easy compared to if you're using Spigot, because all you have to do is just run it. Run the main method here. So It literally takes 2 seconds, and that's it. Literally, it started up. That's the entire thing started up because it's so bare bones that it doesn't have all that fluff that other libraries do, and it's so fast to start up. So now we have a Minecraft server that we can join. So let's boot up Minecraft. And then now when you do direct connection or add server, the server address will just be localhost because it's running on your computer. You don't need to specify the port because we're using the default port, which is 25565, and then just click join server. And look at that. We are now in our flat world, but you'll notice one thing right away, there's no light. So even though we have the sun and the clouds, there's no light. So that is interesting. You can you can break blocks if you want to, but you'll notice that none of the blocks actually drop anything. That's because not only is the lighting not implemented, but block breaking is not really implemented, so you have to actually handle that logic yourself. Literally every aspect of this is not implemented, okay? So this gives us the benefit of customization. We can do everything from scratch and customize it how we want to, but also it leaves us a lot to actually do because we have to implement a lot of basic stuff that we might just expect to work with other implementations for servers. But as a start, this is pretty cool, right? Now we're able to join our server and, run around and do stuff. Not really do much, but it's cool that we have something at least, right? And it's all running just using our IDE. It's literally just running through our IDE. In a future video, I'll show you guys how you can package this into a jar file that you can distribute just like a regular server. And that way you'll be able to run it whenever you want. You don't have to use, an IDE to run it. You just have a basic Java executable file pretty much. Another cool thing about being able to run it in your IDE though is that now we have the benefit of debugging. So we can run it in debug mode if you know anything about that from Java development. And that basically means is that whenever we're trying to solve bugs or just figure out how our code is running, we can run it in debug mode and run the code line by line and just watch how it goes through during runtime. So that's really powerful because you can't do that with like Spigot, for example. But hopefully you're finding this interesting so far. So let's go ahead and add lighting. So you can add lighting by doing instance container, which is our instance, and then you could do set chunk supplier. And to this, you can provide the lighting chunk and then do : new, which will just, create a new instance of that and pass it in. So this will be the default lighting system for Minecraft. So whenever chunks are sent from the server to a Minecraft client, which is my game that I'm running on my computer, it will automatically add the lighting. That's why there's no lighting currently. But of course, in the Minestom spirit, this is all customizable. So you can provide your own lighting system if you want to. But this is how you can add the default lighting system. So now if we go in and restart this by clicking this button here, it's going to take literally 2 seconds to restart. It's literally already done. So now we can go ahead and rejoin and boom, now we have light. So that's beautiful. So now it should function how you would normally expect with a Minecraft server or world. That's great to have. Another thing you'll notice is that we don't have our skin. So this is just a default skin that was generated for us. And that's because we're not using the Mojang authentication right now. You can think of your server being in offline mode if you know what that is. So essentially all we have to do, it's just a one line piece of code, thankfully. We just go down here, wherever you want to put it, and you just do Mojang auth.init. So what this will do is enable online mode, add skins, and etc. All right, we're back in the server now, and immediately you can see that I now have my Santa skin, so it's working perfectly. Something you might notice is that whenever you run the server, it says no SLF4J providers were found. This is what you can use for logging. So we just need to add the logger basically as a dependency to our Gradle file. I'll have a link to this in the description below, but this is the dependency that we need. Just come here, make sure you find the latest version of it though. Go to, at the time of recording is 2.0.16, so I'll click that, and then I'll click Gradle Kotlin because that's the one I selected for my build system. And I don't know why it says test implementation and not implementation, but anyways, just copy this, Control-C, copy, and then come here and go ahead and paste that in your dependencies, and then change it from test implementation to implementation. And once you have done that, go ahead and click the little icon right there to bring in that dependency to your project. So now it has been added, so we can go ahead and restart our Minecraft server now, and it should work. We should have logging now. There we go. So it says hello world, and then it also says these logging messages here. So starting Minecraft server or Minestom server started successfully. So there we go. That's how you can add simple logging using the SL4J simple logger, okay? And that's pretty much all I want to show you for this episode, guys. This is how you can create your very first Minestom Minecraft server. Now that we have a server created, we saw how to create a server, create an instance, how to generate the instance, add lighting, add an event handler so a player can join the server and spawn, enable skins and all that stuff, and then also specify how to start the server. Now that we have all of that set up, we now have laid the groundwork for being able to add more functionality like breaking blocks and dropping items and literally everything that you would expect for a server. Anything that we want to add really, because there is nothing. It's a blank slate and we can add whatever we want to this Minecraft server now, okay? Now that you've seen this, you can probably see that if you've done any bucket or spigot development, this is way different now. So this is not just a plugin, it's literally the entire server from the ground up, okay? And you get a lot more, custom functionality. You can do whatever you want. So with that said, I also want to thank everyone who joined the stream from a couple days ago. In the stream, I was checking out Minestom for the first time, and I just want to thank you guys for helping me out, because it's definitely very tricky as a learning curve, because everything is just not set up for you. You got to do it all yourself. And thank you to all the guys who were there to help me out, because they had experience, and I just appreciate you guys. Thank you so much. All right, that's it. Thanks for watching, everybody. Peace. Hey, what's up, guys? Welcome back to another video on the Minestom Minecraft server development series. In this video, I'm going to teach you guys how to do event listeners. So I just want to first of all say thank you guys so much for the support on the last video, the first video of the series, creating your very first Minestom server. It got over 3,000 views just under 24 hours, which is just crazy for me as a small channel. And yeah, the support on that was crazy, and I really thank you guys for sharing the videos and also just liking the videos and watching, okay? Thank you so much. But from that, I was able to tell that you guys are excited about this new stuff here, because it is really cool. And I'm also very excited as well, because, just the stuff that this has is really game-changing for creating, custom experiences with Minecraft servers. So when we learned how to create the server last time, we, created the server, set up the world, told it how to generate the world, added lighting. But we also used this thing called the global event handler and added a listener to it that will listen to the async player configuration event. So we're going to focus on this aspect of things, event listeners. So what is an event? If you don't know what it is, the most high-level basic definition of event is just something that happens. I know it's kind of broad, but it could be anything like player events, so player breaking blocks, dying, like anything that a player can do. And then you have other events for literally everything that happens on a Minecraft server, just every aspect of a Minecraft server. So what I'll actually do is show you guys how to see all of the events available to us. So if we head to the minestom.net website and we go to Javadoc, these Javadocs here gives us all the documentation for all the stuff that we have available to us in the Java code for the library. So if we just go down to net.minestom.server.events, this is the root package for anything event related, so we can click that. And then it breaks down into different types of events. So we have the player event, like I just told you about. We have server events, item events, inventory events. So like opening an inventory, closing an inventory, clicking an inventory, changing the items in inventory, all kinds of stuff like that. We can look at entity events. So entity death event, despawn event, all kinds of stuff like that. Player. So there's a lot more for player, because those are probably the most important ones, I would say. But the point here is that we have all of these things that could happen in game, like in Minecraft, and these events are classes that represent something happening. So if we look at the player block break event, this represents a player breaking a block, okay? And so since we have these events, what is really cool about that is that we can add listeners. We can listen to these events in our server code, so that whenever these events happen, we run whatever code we want to run. So in this specific example here that we already did before, we're adding a listener to listen for the async player configuration event, and then we're giving it a block of code that will be run every time that this event is triggered. So the server will always be listening to events. When this particular event happens, we'll run this piece of code here, okay? And so if you want to find out what this specific event does, you can look at the Java docs, or you can do Control Q, and you can check out the Java docs within your IDE. It may say like at the bottom, like download Java docs or something like that. Just make sure you click that for the first time. But it says called when a player enters the configuration state, either on first connection or if they are sent back to configuration later. The players move to the play state as soon as all event handles finish processing this event. So what this means is that basically this is the event that is triggered when a player first joins the server, so that you can set up their configuration. So in this case, we're getting the player that joined the server, we're setting their spawn world, and then also where in that world we're going to spawn them. So the capability of being able to listen to events using event listeners gives you a lot of cool stuff, a lot of capability, because you can have your server do stuff that otherwise it would not do, obviously. So if a player dies, for example, there's the player death event, you could listen to that and then run some custom code every time a player dies, like take money away from their account, print a message to the chat, anything like that. So you have a lot of options, okay? So the global event handler is just the basic way that we can add event listeners. So let me go ahead and add another one. When we joined the server last time, we saw that whenever we broke a block, it did not drop anything because that's unimplemented. So the way that we can implement that is by actually implementing the block break listener. and customizing, what happens when you break a block, which should be to drop the actual block as an item, right? So let's go ahead and figure that out. So we're going to do global event handler, and then we can do a bunch of stuff here, but the ones that we really care about at the moment is add listener. And now what you want to tell is what class you're trying to listen to. What specific events are you listening to? So player block break event dot class, and you can find all these names, of course, like I said, on the Java docs, or just typing them out using the autocomplete is also very helpful most of the time. But yeah, once you have told it what class you're going to listen to, what event you're going to listen to, now we can give it a lambda, a consumer, which is representing what happens when the event is listened to. So we can just do events arrow and then open the curly brackets, or you can do control space and then just press tab and it will autocomplete all of that for you. So one thing I like to do though, which is very common, is change this name here from this long name to just events. It's just easier to call it that way, or E, whatever you want to name it. But yeah, this variable here represents the actual event itself, and it gives you all the information from the event. So we can do event dot, and you can see that it has all this information here. So you can see the block that was broken. It even tells you in the documentation. You can see the player who broke the block face, the block position, so the XYZ coordinates of the block. You can cancel it, which we'll talk about in a second, but all kinds of cool stuff, right? So that's how you extract information when an event happens, which is very helpful. So let's put that to the test. We're going to do S out. We're going to do events.getPlayer, so the player who broke the block. Let's just go ahead and get their name. So get display name, and we'll say has broken a block. And this code alone should add an event listener that should listen for the player block break event, okay? So let's go ahead and start the server up and join it and see if it works. All right, I'm on the server now, so let's try breaking a block. Okay, so as you can see, nothing dropped, but if we check our console now, it says null has broken a block. So that's weird. It says null instead of the actual display name. So, and it explains it here. So when we do control Q to see the documentation, it says it returns the player's display name. If it says null, this means that the username is displayed instead. So I'm assuming what that means is that a display name has not been set for the player. That's why it doesn't have anything to show. So I'll go ahead and do get username instead, and that should fix it. Let's try it again. Okay, back on the server. Check the console. There we go. So it says Illuminati has broken a block. That's my name. And there we go. That's how you can make a simple event listener to listen to the player block break event, which is simply listening to events. Pretty cool, right? So now let's make it so that it actually does what you would expect on a vanilla server. So it actually drops the block that was broken. I'm going to make a more detailed video on items, but for now, just try to follow along the best you can. And I'll explain it as I go along, okay? So the first thing that we're going to do is do var material and just get the material of the block that was broken. So get block.registry.material. I'll also have a video on blocks as well. I'm going to explain as much as I can. So we're getting the material of the block that was broken. So for example, if we broke that grass block, it would just be grass underscore block. Material is an enumerator. So we can do material. If it's not null, we can go ahead and do var item stack. So we're creating a new item stack dot of material. So we're saying create a new item of the type material. So it should be like a grass material item stack. And then now we want to do an item entity. So item entity is equal to new item entity. And this we're passing in the item stack. So this represents the item, but this is actually an entity that will be spawned on the server. So an actual like floating item icon thingy that appears whenever you drop an item, for example. That's what that is. So that's the item entity. So we're creating that item entity out of the item stack with that material. And then we need to tell the item entity where to spawn. So set the instance of it. Set instance. We're going to set it to, we can set it to the instance container, the one that we created above, or we can make it so that it works in any world. So we could do like event.get instance. So you can get the instance from the event itself, the instance that the block was broken in. And then also to set instance, it's asking for the spawn position of this item entity that we have. And we could do that by doing event.get block position. So that will get the block's position where the block was broken and spawn that item entity in that, coordinate. And then the last thing that we want to do is add something called the pickup delay. So item entity.set pickup delay, and we'll do duration dot of millis 500. So thankfully someone on stream explained this to me. Otherwise I would not have figured this out very easily. Basically the pickup delay is how long after dropping the item before you can pick it up. That's pretty self-explanatory, but if you don't have it set, then you can't really drop the item because you instantly pick it up, or it just doesn't work at all. So it's really weird. I don't know how you're supposed to just know this like without any like direction, but Yeah, you got to have that or it just won't work. Okay, so make sure you have that. So we're saying as soon as we drop this item, it has 500 milliseconds and then it can be picked up by a player or someone else. And you can customize that number to be whatever you want. I think 500 milliseconds is the actual number that Minecraft uses, but I could be wrong about that. But yeah, this is everything that we're going to need to spawn the item after breaking the block, okay? So just as a little recap here, we're listening to the player block break event. We're going to print a message to verify that it has occurred, and we're listening to it. And then we're going to get the block's material. So we're storing that in a material variable. If it got it, then we're going to create a new item stack of that material, create a new item entity so that it can actually appear on the ground as an entity using the item stack, which we'll talk about more in a future video. Then we're going to set the instance of the item stack, so tell it where to spawn, the position in the world, right? And then we're setting the pickup delay of the item entity to make sure that we can actually drop it and then pick it up after 500 milliseconds. So I know a lot of you who are watching these videos are familiar with like Bucket and stuff like that, but for those who have never done any sort of Minecraft programming before, this may be a little overwhelming because it's a lot of information here, but I promise you the more that we make stuff like this and the more videos that you watch, you will start to understand it, okay? Anyways, let's actually go ahead and test it out by restarting the server and try breaking a block. See if it drops some grass. Okay, I'm on the server now, so we're going to do boom. And if you look closely, there is a floating little block here, so it works perfectly. Look at that. So they're just hiding in the corner. And then you can see that as I pick it up, it just disappears. That's because we have to listen again to another event for the item pickup event to make it so that whenever an item is picked up, it actually adds it to our inventory. So again, nothing is implemented. We have to implement it ourselves. Pretty cool that it's working though. So to make it actually appear in the middle of the block, as you might expect, not in like the corner hidden, you just have to go back to your code. And in the place where we're setting the spawning XYZ of the block, or of the item rather, we can do add, and then we could do 0.5, 0.5, 0.5, and that will just center it for us. There we go. Look at that. Beautiful. All right, so that's how you can create event listeners and add them to the global event handler. Very useful stuff. Now I'm going to teach you guys about event nodes. So nodes are a way to organize event listeners and create conditions for them. All right. So not only can we create event listeners like we've done above with these two things here, but we can create something called event nodes, which can sort of encapsulate them and organize them into different ways, essentially, okay? So to create an event node, we can do event node, and then it wants a generic type, so we're just going to go ahead and do event. We're going to call this the all node, and we're going to say event node from Minestom dot, and we have all these different options here. We're going to do all, and we're just going to give it a name, so we're naming the node. We're going to call it all. Yeah, just all, that's fine. So again, a events node is just a way of organizing your event listeners. So an event node can have listeners within it, okay? So since we're doing event node.all, we're basically saying that this can have event listeners of any type within it, okay? So just like our global event handler can have any type of listener, so can this event node. The reason though that you would want to have an event node is just to organize listeners into this little thing here. So even though they're a little bit similar in the sense that they can accept any listener, it creates organization because you can have different nodes and different nodes can inherit from other nodes and all that kind of stuff that we're about to talk about, okay? So with that said, we can do all node dot, and we have all these methods here. There's actually a lot, but one that we care about is called add listener, the same one that we used above, which we can use to add a listener to our event node. So we're going to add the pickup item events listener, or class rather, and we're going to implement the pickup item event so that we can actually put those items that we pick up into our inventory, okay? So just like before, this event here will have all the information about what happened or what the event contains. So event dot, we have the living entity, the person that actually picked up the item. A living entity can be stuff like a player or just other types of entities. The item stack that was actually picked up, the world, the instance rather. Then we have get entity, which I believe is different from living entity. Living entity is the person who picked it up. Get entity is actually the item entity itself, but you also have get item entity, so I really don't know the difference. Anyway, so let's just go ahead and print out a message. Player picked up an item. Okay, and then once you have the code for your event listener here, it's now part of this node, right? Because we used add listener, but now this node here is just kind of floating in space. We have to add this node as a child under our global event handler. Since the global event handler is the global event handler, this is the thing that encapsulates all of the event nodes that we can use to listen for events in our our server, right? So any event node that we have that we create custom, we need to add as a child just to that, okay? And we could do that just by doing global event handler dot add child. So we have add listener. Now we're going to use add child, and we can just pass it our all node thingy. So what that will do is add our event node, but since our listeners are inside of that, it will also add our listeners, okay? So if we go ahead and rerun the server now, so we should be able to break this block and pick it up. And then in the console, there we go. It says player picked up an item. So it worked. So now we're able to create our very own event node, add a listener to it. And yeah, so you can add as many event listeners to this node as you want to. You could organize it however you want to. So it makes more sense, in my opinion, to add listeners that sort of go together. So if you have like a mini game or something that's running on your server, then you can add all the listeners, relevant to that mini game to the, event node with like mini game node or something like that. Okay, so just put them together is what I'm trying to say, because of course a event node is a way of organizing listeners. Okay, but yeah, let's go and actually finish implementing this event listener here so we can actually pick up the item. So whenever the player picks up the item, let's go ahead and get the item that was picked up. So var item stack is equal to event.get item stack. And then now we want to, we have event.get living entity. I happen to know that a living entity can be a player. This is just kind of one of those things that you learn as you start working on stuff like this. So if you do something like if event.get living entity is an instance of player, that's just using instance of pattern matching. So it's saying if the living entity who picked up the item is a player, then cast that to a player. Now we have this player variable. So now we want to do player.get inventory.add item stack. Pretty simple. So we're listening to the event, printing out a message, getting the item stack that was picked up, and then getting the player who picked up the item stack if it was a player, and then adding it to their inventory because right now it doesn't. We're actually implementing that logic, okay? So let's go and restart this and see if it works. All right, pick it up, and boom, there we go. We have picked up our grass block, and we can actually put it down if we want to. Perfect. So now we have not only figured out how to add a listener to our event node and add that event node to our global handler, but we can also now pick up items. So pretty cool stuff. So something that event nodes is also good at is, like I said before, you can create conditions for them or filters. So let's go ahead and create another events node. We're going to leave the type as a question mark for now, just for now. We can call this the player node. So the player node is equal to events node. And we have these different methods here. So before we used all because we want to target, we want to allow this event node to have all listeners within it of any type. But the thing that we can do now is also have it filtered by different event types. So if we do event node.type, double click that to complete, we can give it a name first of all. So every event node needs a name. We can call it the players event node, for example. And then now we can set a event filter. So this is how you want to filter the events that are allowed to be part of this event node. This gives you another layer of organization for your event node, okay? So what this means is that not only can you put whatever listeners inside of this event node that you want to organize them in whatever way you want, but you can also have it be a specific type of event. So for example, we can do event filter dot with these different options here. So we have block, we have all, entity, instance, inventory, item, and player. So these are all the main different event types that we showed before in the Java docs, if you remember. So if we were to set it to, for example, player, now what this means is that this event node can only have within it listeners for player related events, okay? And then now with this question mark here, just change this from a question mark to player event. It's also kind of easier if you just do var. That way you don't have to worry about setting the type manually yourself. But yeah, so now we have this player node here. Like I said, it can only have within it listeners for player related events. Of course, if you're curious on like what is a player related event and what is not, you can again go back to the Java docs. Let me pull that up again. Event. We have these different categories that corresponds to the filter, the event filter I just showed you. We can look at player, and then if you just click one of these, like the player block place event, you can see that it implements the interface player event, also a bunch of others, but player event, click that. And so here's all of the events that implement this interface here. So these are all going to be the events that are going to be allowed to be inside of your event node if you listen to them, okay? So we can do something like player node dot add listener, and we can do the item drop event. I just happen to know that's a player event because I checked ahead of time. Another way that you can tell really quickly is by holding control and just click this, and you can see that it implements the player instance event. But if you click this, this implements or extends the player event. So you just know that it's a player event, okay? If you don't do a player event, if you do something random like the entity tick event, for example, this is it's gonna warn you right away because it doesn't pass the filter, the events filter of player, okay? So it's just smart enough to know which ones you can add a listener for and not, which is awesome. Anyway, so just like before, it's the same process for actually handling this. So we can do events, open that up with a lambda, and then now we could say player dropped an item. There we go. And so now we have added a listener to our player node, which is a events node that filters out anything that's not a player event, okay? And what we can do is add this node also to our global event handler so that we can actually start listening and test this out. Because if you don't do that, it's just like I said before, floating in space. You need to actually add it as a child somewhere, okay? All right, I'm back on the server now so we can test it out. So let's go ahead and break that, pick it up. Now we'll try dropping it by pressing Q and disappears. Nothing happens because we have not implemented it yet. But if you check the console, it says player dropped an item. So this is working perfectly. So yeah, that's another way that we can create event nodes is by doing event node.type so that we can filter out or keep only the events that match this event filter. So player, for example, right? Pretty cool stuff. So let me show you guys how you can implement this one as well. Don't focus too much on the code actually part of the handler because again, this video is supposed to be about event listeners, not like entities and stuff like that. So focus more on the listener part of this, but I'm sure you're curious on how to do this as well. So like you saw just a second ago when we pressed Q to drop the item, nothing happened. So that's the part that we actually need to implement. So we're going to create a new item entity, just kind of like we did above when we broke the block. We wanted to spawn an item, right? So we're doing item entity is equal to new item entity. And from the event, we can do event.getItemStack. So we're getting the item that was dropped, creating an actual entity out of it that will appear on the floor. And then we can do event entity.setInstance, just like we did before as well. Event.getInstance. And then now we want to set the spawn position of the item entity, right? And you have to kind of think about this. It doesn't just like appear somewhere like on the floor. It appears out of the player and like launches out of their body, right? When you drop an item in a regular world. Because it does like the little animation, right, if you throwing an item. So the spawn position of this item entity that we're spawning should be in the player basically, and then have a velocity where it moves outward, okay? So this is again getting a little advanced, so don't freak out too much if you don't understand what I'm saying here, but let me just show you what I mean. So we're gonna do events.getPlayer.getPosition. So this will get the XYZ position of the player. And then to actually make it move, like launched out of their body, we can do item entity dot set velocity, and we can do events dot get player dot get position dot direction, and then multiply by 6. So what this will do is get the XYZ position of the player, get the direction as a vector, which is getting a little into like math and stuff like that, and then multiply that vector by 6 to give it a higher velocity. So it should, go farther. And faster. So that's what that will do. A little complicated. And then something that you can do to improve this is you can go to add position, you can do add, and you could just add onto that to make it a little taller. So it should launch not from the bottom of their feet, but like from the middle of their body pretty much. So after that, we can now do item entity dot set pickup delay. Same reason as before. We do not want to have an issue where we can't pick up the item. So that will make sure that it works. And that's it. So let's go ahead and test it out. All right, we're back on the server now. So let's go ahead and pick this up. Boom. Let's go ahead and drop it. And boom, it dropped. A little laggy there, but it dropped. So you can see that it's not really going too far. So what you can do is have some fun with this. The whole point of Minestom is to make it as customizable as possible. So you could really have some fun with this. If you want to, you could multiply it by like 20, and that will obviously increase the force in which it's thrown pretty much, the velocity. So let's try this out, see what that looks like. Boom, let's throw it. And look at that, it goes way farther, so we can pick it up, play catch with ourselves. So look at that, just launches now because it has a crazy velocity. So let's make it like really high, like 2000. I don't even know if it's gonna appear if we do that. Let's try it out. Let's send this item to heaven. How about that? Boom. Look at that. Yeah, it never came down. That's crazy. Look at that. It's so fast that it just disappears right away. That's crazy, man. All right, but yeah, that's how you can add custom functionality and implement the drop item event. But that's also, again, how you can add a event node that filters out only for player events, okay? So the last thing I'll show you guys is not only can you add a event node that filters out only specific events, but you can also add conditions to that as well. So you can filter and add conditions. So what we're going to do is do var, and we're going to just call this something like grounded players node. It'll make more sense in a second. And for this, we can do events node dot, instead of type though, we can do dot value, and then we can give it a name. We can call it grounded players. And then we can do event filter dot, and we can choose whatever type of filter we want. Let's just do player again. And then onto this, we can also add something called a predicate. A predicate is basically just a function that evaluates to true or false. So this will give you a player who is part of the event. And basically what you can do here is give it a condition. So these events that you add as listeners to this event node here will only apply to players who pass this condition. So for example, we can do something like if player.is, and we have all these different booleans here, like crazy amount, like is glowing, is invisible, is on fire. So you can basically have listeners that only apply when the player is on fire, for example. We can do is on ground. So we can do return true or return false. We could simplify this as well, like that, and then like that. And so now we can add whatever listeners we want to add to this, as long as they're player listeners, because we still have this filter here. But these listeners will only apply to players who are on the ground, okay? So this is something that you cannot do with other frameworks. Like having these built-in conditions for your event listeners is just really, 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 really cool stuff that I've never seen before. Let's add a listener that can, test this out. So grounded players node dot add a listener. And let's go ahead and do the player start sneaking event. So as you can imagine, this is an event that is triggered whenever a player starts sneaking. So when they press shift. So let's add the thingy here for that, the lambda. There we go. So we'll just print out some code. We'll say player started shifting on the ground. Before we can test it though, we need to make sure that we register this grounded players node that we have. So let's just add it to the global event handler as a child. So we're going to do global event handler.addChild.grounded players node, just like that. And then we'll join the server and see if it works. Okay, I'm on the server now, so I'm going to try shifting while in the air. So boom, so that should have done it in the air. And look, in the console there's no message, but if I do it now on the ground, boom, then there we go. We get player started shifting on the ground. So as you can see, it's only applied, the event listener is only applied when the player is on the ground. So that's just one little tiny basic example of how you can create event nodes that can not only filter out certain events, but also filter out events for specific players or whatever the event is about. In this case, because it's a event node filtering for players, it's going to be based on a player. So that's the basics of event nodes, the different ways that you can create them and add listeners to them. But something important is that you can create a hierarchy or organize them in a way where you have parent nodes and then children nodes under that parent. We're already kind of doing that with the global event handler. So we're doing global event handler.addChild, and we're just adding each of these event nodes as children. But we can also do the same thing with any event node that we have. So if we want to make the grounded players node a child of the player node, we can do that, which kind of makes sense, right? This is a player event node, and this is a player event node, except that it's filtering out players that are only just on the ground. And when you have an event node as a child of another event node, it inherits all of the filters and stuff like that from the parent, okay? Just as you might expect. So let's go ahead and try this out. So instead of doing global event handler.addChild for the grounded players node, let's go ahead and make it a child of the player node. So all we gotta do is do player node.addChild and then grounded players node, just like that. We can do the same thing for the all node and player node as well. So we can do all node.addChild player node. We just need to add it right here, of course, wherever you want to have it, but we'll just add it right there. So now the relationship is like this, where you have all at the very top. So this is allowing all events of any type. And then under that, as a child, you have the player node, which is going to allow all player events. And then as a child of the player node, you have the grounded players node, which will, of course, like I said before, do players that are on the ground. Even though this is a very basic example of how you can create these hierarchies and have like a tree of different nodes set up however you want it to, this can get very complex, of course, right? And you can use this to your benefit to organize your servers. organize the way that your servers do event listening. So you can have it as a hierarchy depending on what you're trying to do. So let me just show you an example so it's a little more clear to you guys. This is available on the Minestom documentation. So just as an example here, you have the server, and then within the server you have a lobby event node and a game event node. And then within the lobby event node, which represents the ranks of the server, you have the default rank, the VIP rank, and the admin rank. These, you can kind of make up what these will do, but you can probably imagine that these event nodes here will target specific players with these ranks here and apply different events to them depending on what rank they have. You also have game, and then within game you have a Skywars game, and then depending on the kit that they have, you have these different, event nodes here as well. So same kind of concept. Here's another example here. This is how they would recommend that you structure your project. That way you have good documentation, and also it's clear how the event nodes are filtered based on the inheritance of the different event nodes. So use packages for major nodes, and then use classes for minor filtering. So you have the top level server package, and then you have global, which I would assume is the global event node. And then you have lobby, rank, and then you have these different ranks that can represent the different event nodes. And yeah, so this is how you can organize your event listeners for your server. This is obviously much more complex than what we're going to be handling in this episode, but it's just important that you know why event nodes are important, and then also how they can be used in the future to enhance your project, okay? So with that said, I want to show you guys a couple more things before we end this episode. I know we've learned a lot so far. So now I want to show you guys how you can make your event listeners even more advanced here. So instead of just using a Lambda and just having the code that will be run whenever this event happens, you can build a more complex event listener. And let me show you how. So let's just get rid of all of this and replace it with event listener dot builder. So as the name implies, what this will do is allow you to build a event listener, but with a lot more options. That makes it a little more advanced. So instead of the builder here, you're just going to pass in the event type that we're trying to listen to, which is the player start sneaking event dot class, same as before. And then now we could do dot on the builder, and we have these different methods here that we can use to give our event listeners a little more customized settings here. So let's just start with handler. So handler, double click that to autocomplete. This will be the actual event listener code that we had before. So this is just looking for a Lambda, a consumer. So we can control space to complete that, open that up, and we could again print out a message, player started sneaking on the ground. And then once you're done doing everything with the event listener builder, just make sure that you do .build at the very end. That will actually build it and then provide it to the add listener method that you're calling. So let's test this out just to make sure that it works still. But so far this is doing the exact same thing that we had before. Nothing is different, just the syntax. All right, we're back on the server now, so we can start shifting. And there we go. We get player started sneaking on the ground, player started sneaking on the ground. So it's working pretty well. But let's take a look at these other things that we can add. So we can do dot, and we could do expire count. And if we check the documentation, it says it removes this listener after it has been executed the given number of times. So if we set the expire count to 3, this means that if this event listener here is fired 3 times, it will remove it from the node, so it will no longer listen to that event, okay? So let's go and try this out. Okay, we're back on the server. We're going to shift, shift, and shift. So we get it 3 times, and then if we do it again, shift, let's do it a bunch of times, nothing else happens, because after the 3rd time, since the expire count is 3, it removed this event listener from the node. So that's really cool. This is not something I've ever seen in another framework. Maybe it exists out there, but I have not seen it. Basically, you've given a event listener a way of expiring itself or removing itself from the from event listening. So that's pretty cool. Another thing that you could do is the expire when. So expire when is very similar. It's not taking a count though, it's taking actual condition. So when this condition becomes true, then it will actually remove itself just like before. So we can try this one out. It's asking for a predicate, which is basically a lambda that evaluates to a boolean, true or false. So we can autocomplete that. So we're given the player start sneaking event, which is the same thing that we have down here. So this contains all the information about the event that we're listening to. So we can use that to evaluate some boolean or condition that we want to have that will, when true, remove itself from the event node, okay? So just something basic that we can do is if the player is holding a specific item, let's say that we expire this, okay? So we can do something like if event.get, not event, player start sneaking event dot get player. So get the player who started sneaking. Let's get their inventory, get the item in their main hand, get the material of the item, and then say if it equals material grass block. That's the only block that we have on our server. If that's true, if that is true, then we're just going to return true, and we'll also just send them a message. So player start sneaking event dot send message or get player dot send message. And then otherwise, if that condition is false, then return false, so it will not expire, okay? So just as a recap here, what this will do is build a event listener for the grounded players node, and what it will do is basically listen to every single player start sneaking event, but after the third time, it will expire, so it will remove itself from the event node and no longer be listening. Otherwise, there's also a condition that when it becomes true, it will also expire and remove itself. So the condition in this particular circumstance is that whenever the player triggers the player start sneaking event, and they also have a grass block in their hand, it will expire, and it will not hit the listener. It will remove itself, okay? Okay, we're back on the server, so let's go in and shift, and then let's get a grass block in our hand here. So it says we shifted twice, that's good. And then if we shift again, it says you found a grass block, good job. If we check the console, it did not print the player started sneaking on the ground message because it expired before it was able to reach the handler here. So it checks the condition before it reaches the handler. So since it expired because this became true, it removed itself and it didn't hit the third time. So basically this event listener that we have here has two ways of expiring. Either it hits 3 times or it expires because the player is holding a grass block, okay? Something else that you can do is add a filter. So similar to how we're adding the filter to make sure the player's on the ground for the whole event node, we can also add filters on specific event listeners as well. So we can filter, and this is going to be a predicate with the events, just like the one above, except that whenever this is, whenever this occurs, it's not going to expire. It's just going to, filter out whether this is going to handle or not, okay? So we can do player start sneaking event dot get player, and we could just say if they're glowing or if they're eating or something like that. If they're eating, then return true. And all this code here will do is that if this is true, if this evaluates to true for the filter method, this means that this will not handle, okay? So this means that it will only apply to players who are currently eating, okay? So this is just another way of adding another layer of filtering on your event listeners, which is really cool stuff. And that's all I want to show you guys for the event listener builder. That's how you can build more complex event listeners rather than just having the like up here where we do the class and then just have a lambda. That's a really good way of doing it, but if you want to have a little more advanced settings like the expire count, expire when, and filter, you can use the event listener builder, okay? All right, so the last thing I want to show you guys, I know this episode is getting pretty long, is how to cancel events. So something that you can do is if you go to any event that you have and just hover over it actually, it will tell you the different interfaces that it implements. And sometimes you will see that some of them inherit from cancelable event. And that simply means that an event can be canceled. And what that means for us is that whenever you have an event that is cancelable, inside of the handler, you can do event.setCanceled. And what this will do is if you call this and pass in true, this will cancel the event and make it as if it never happened. So in this specific example here for the player block break event, if we cancel that, this means that the player cannot break any blocks. Nothing will happen. It will look like nothing happened basically, okay? All right, I'm back on the server now. So if I try breaking a block, nothing will happen. So it cancels, and this means that the block will not be broken. So that is what it means to cancel an event. You can do that to many of the events that we have available to us. Some of them you can't, but a lot of them you can. And this is very useful actually because you can prevent the player from doing stuff. So just as a very basic example here, if on a Minecraft server you have a player like in the spawn area and you don't want them to be able to break stuff in that area, you could check to see what coordinates they're in, and if they're in that specific coordinate zone, then you could cancel the block break event so they cannot break a block in that area. That's just one example of how this could be useful, okay? Another thing is if you want to have a server where a player cannot hit other players or hurt other players, you could cancel the player damage entity event or whatever that would be called. That way when a player smacks another player, nothing can happen because the event is canceled. Usually you will have some if statement controlling whether to cancel this or not. It will check something, and if that is true, it will cancel the event, otherwise it will not. In this case, since we have no condition here, it will cancel anytime a player breaks a block no matter what. So, and yeah, that's pretty much it for this video, everybody. I really appreciate you guys watching, and again, thank you for all the support. Hopefully you guys learned a lot in this video as well. Now you guys should know how to do event listening, how to do event nodes, which is really cool. It gives you a lot of organization and capability for filtering out different types of events and adding conditions as well. And finally, you guys should know how to use the event listener builder and also how to cancel events. All very useful stuff, and I hope you guys can use that to make your Minecraft servers even more advanced. Stay tuned for more videos, everybody. More to come. Very exciting stuff. Hey, what's up, guys? Welcome back to another video in the Minestom Minecraft server development series. In this video, I'm going to teach you about commands. Welcome back, everybody. So hopefully you're enjoying these videos so far. So far, I've shown you guys how to create a Minecraft server using Minestom and also how to do event listeners so that we can listen to when things happen on the server and then also run some code when those things happen. Now we're going to move on to something else that's pretty exciting, which is commands. Now, hopefully you know what a command is, but whenever you join a Minecraft server, you can run commands like /help, /kill, /TP, stuff like that, right? You can do maybe /send message. And normally within Minecraft servers, you have things like plugins that will add new commands to servers. So if you've ever played like a faction server with your friends, then you're going to see a lot of different commands on there versus like a creative server or a survival server, for example. The thing is though, with Minestom, there are no commands at all. Not even the vanilla command. So if we do /, nothing appears. And there's no /help, which is like the most basic command that you could always do. And that of course goes with the theme of Minestom where everything is, blank slate and you can add whatever you want. So that's why I'm going to teach you guys how to make commands with the Minestom server. It's pretty easy actually. The API is really cool. So when you create your commands, you're going to be creating classes for each of the commands. So I highly recommend you make a package called commands. So new package called commands within whatever your base package is called, okay? So in that folder, you can just add all of your commands and you could have subpackages if you want to organize your commands further. So I'm just going to add a new command, a new Java class. We're going to call it the fart command. And then you just need to do extends command from Minestom. There we go. And now we just want to create a constructor for this class here. So we're going to do public fart command. And something that we have to do is do super. And then to this, you can provide the name of the command as well as optionally some aliases for the command. So the name is required though. The name will just be fart, right? So you can do /fart, that's what the command would be. And then if you want to, you can add a var args list of aliases, which are just another way to run the command. So we could do like poot or toot. You can add as many as you want, okay? So now with this alone, we have a basic command that we can run using /fart or /poot and toot, okay? But it won't actually work yet because we have not added any executors or syntax. So that's the first thing that we want to do. We want to add something called the default executor. So set default executor, and then you can do control space to autocomplete, and then press tab. This will create the lambda for you. And then within this is the block of code that will run whenever you run just this base command here, /fart, okay? Or any of the aliases. So to this, you have the sender and the context. The sender is the person who ran the command. It's a command sender if you do control Q. This can be the player, if it's a player on the server who ran the command. It could be the console if you run it in the console, or it could be a command block, stuff like that, okay? So usually it's going to be a player though, obviously, right? But whenever you need to do something player specific, you would cast this to a player, all right? And then the context is just, as it sounds, the context of the command. So you can grab information about the command from the context, like the command name, the input, just basic stuff like that, okay? But let's focus on the sender. Let's test this command out by sending the sender a message. So we can do sender.sendMessage, and we could say whatever you want. You could say, you farted stinky. So gross, right? So again, this will be the code that runs whenever we run the command, but specifically the default executor is the code that is run when either there are no arguments provided or nothing matches. And you'll see what I mean by arguments in a second if you don't know what I mean. But for right now, all this means is that this will be the code that runs whenever you run the base command, just /fart. And that's all we need to get started to actually test this out. Now what we need to do though is register the command. So go back to your main.java and just scroll down to the bottom or just wherever you want to put it. And we want to go ahead and do Minecraft server.get command manager .register, and then you want to pass in an instance of the command that you just created. So this is going to be new fart command. There we go. So now we have registered our command with Minestom, and Minestom will take care of doing all the stuff behind the scenes, and now we could use the command on the server though to test it out. So let's go ahead and restart, and let's see what it looks like. Okay, I'm on the server now, and so right away if you do / and do F, you can see that it's auto-completing fart for you. So the command is definitely added to the game. It's now available for you to use, and if you press enter, it says you farted stinky. Damn. You're nasty. That's the most basic way you can create a command, just with no arguments. So that leads to the next question, what are arguments? If you don't know, arguments are just information that you pass into the command as you're running it. So, for example, if I want to fart 5 times, I could do /fart, then 5. 5 would be the first argument, but in certain commands, you'd have more than one argument. So this would be like 1, 2, 3, 4, 5, 6 arguments to this command here, and I would use these arguments to do different things. So let's take a look at how we can use arguments when we create this command here. So currently this is going to be for /fart, but if we want it to be where we do like /fart and then an amount, for example, like amount, then we need to declare a different syntax for that. So the first thing that we want to do though is declare the actual argument itself, define what the argument is and how we're going to, what the data type of it is going to be. So we're going to do var fart amount arg is what I'm going to call it. And then we're going to do argument type dot, and then you have all these options here. So what's really cool about Minestom is that whenever you're doing commands, it automatically knows the type of the argument. It tries to match it correctly based on the type that you're, selecting here. So basically, if I was to make a command /var and then the amount, then I would want to select argument type integer, for example. So where's integer? There we go, integer. And all we have to do is just give this a unique identifier, an ID, and we're just going to call it the fart amount. So now we have defined the argument that is going to be part of this new syntax that we're adding. So let's go ahead and add that syntax. We're going to do add syntax, control space to complete this. This is going to be the actual code that is run inside of here, similar to how we did it up here. But then after that, so put a comma after the closing curly bracket, put all of the arguments that you want to be part of this command here, this syntax here, okay? So now we have two different syntaxes technically. We have the default executor, which is when you do only /fart, and then you have /fart and then the amount. So this is whenever you provide a amount argument as an integer, and this will be the code that is run for that, okay? So what we want to do is get the argument from the context, right? So we want to get the actual integer that was passed in as an argument to this command here. So we want to do int fart amount is equal to context.get. And now we just tell it what argument we're trying to get, which is the fart amount arg that we created above. So now that we have the actual value that was passed in with a command, we can do whatever we want with it. So just as a test here, we can make a for loop. Let's just do fart amount. So it's going to loop however many times that you pass in as an argument. And for each iteration of that loop, we're going to do send message, you farted stinky, and then we'll add on the index as well, so we know how many times it's iterating, and that's it. So I'll go back and explain this in a second, but let me go ahead and run this and show you what it looks like first of all. All right, we're back on the server now. So if we do /fart by itself, it's still going to do that one. So you farted stinky. But now that we have a different syntax where it accepts an argument, if we try it again and press space, you can see that it's suggesting an argument that we can put here. So the fart amount. So let's just say we do 5 and then press enter. There we go. So you farted stinky 0, 1, 2, 3, 4. So what we're doing first is we're defining an argument, which is an integer, which is the fart amount. And then we're adding a syntax along with that argument, or you can add as many arguments as you want. And this will essentially match the command that you run. If you provide an integer to it, it will match to the syntax here, okay? And it's smart enough to know the data type. So for example, if I go back to the game here, I do /fart Bob, this does not match our syntax, right? So the first argument has to be an integer, right? The fart amount. So as long as you have a number, an actual integer, it will work. If you have anything other than an integer like a string or a double, it will not work. It's really smart. That's what I really love about this API, this command API, because it knows it can handle those data types and validate them for you and match it to the correct syntax that you want. So basically what we have here now is two different ways to run our command based on what they provide to the command when they run it. So if they provide nothing to the command, it'll just run the default executor, which is just this message here. If they provide the fart amount to the fart command as the first argument, then it will run this code here, okay? However, if they also just provide a different argument that doesn't match the syntax here or any other syntax, it will still run the default. So like I said before, Bob is not valid because it's looking for an integer, not a string. So if you press enter, it'll just print out the default executor, okay? So the default executor is for the base command as well as if it doesn't match to any syntax, okay? So let's see another example of how we can add another syntax. Let's just go in and separate our arguments up here. So we'll do fart target. So let's say that you want to have a command that allows you to fart on somebody as well. So we can do argument type dot string. And like I said before, there's a bunch of different data types down here. Like this is really cool. But let's just do a string, right? And we're going to give it a name. So we'll call it the fart target. And now if we wanted to, we could add this fart target alongside our fart amount. And what this would do is match to a command that looks like this. So /fart amount and then target. So it'll only match to this if you provide the amount and the target. If you just provide the amount, it won't work, right? Because you need both. It's just smart enough to know that. However, I just want to add a different syntax that only includes the target. So let's do /fart target. And let's do add syntax, control space to autocomplete that lambda there. Now let's actually try grabbing it. So we'll do string target is equal to context.get. And then now we want to pass in the argument that we're trying to get, which is the fart target. Let me fix that. And so now that we have the fart target, we can run whatever code we want to run for this specific syntax. So we'll just say something like send message, you farted on target. Very rude. Yeah, don't be farting on people, guys, unless you want to. So after that, we can go ahead and add the fart target as the required argument for this specific syntax here. Make sure you don't forget that because it needs that to be able to match it correctly. But yeah, that should be all we need. So let's go ahead and rerun this and see what happens. All right, so we're gonna do /fart. That still works. That's the default executor. And then now, if you press enter, you can see that you have two different options for this. Oh wait, I never updated it. So if we go back here, you can see that I still have two here. Just make sure you remove that one. Hopefully you caught that yourself. Okay, we're back. So we'll do /fart. Still works there. And then now when you press space, you can see it as the fart target and the fart amount as two different options for the arguments that you can provide. And now because Minestom is so smart, depending on the data type that you provide, it's able to match to whatever one that you need. So if we do /fart Bob, it will match to that specific syntax that accepts a string. So it'll say you farted on Bob, very rude. That's what I did, very cool. But then if we provide an integer, so fart, let's say 200, it'll run, our for loop 200 times and print out that message. So it's able to, so I just want to really, hone down the point that it's able to match to a specific syntax depending on the data type, which is, to me, that's just really cool. And yeah, that's how you can make a basic command using Minestom. Now I want to show you guys how to make just another command so we can get enough practice down and show you a few other things. So we're going to do, instead of the fart command, we're going to do the set health command, which will allow you to set your health manually. And the first thing we're going to do always is do extends command from Minestom and then create the constructor. We don't need this though. We just want to pass in to the super the name and any aliases if we have any. So we're going to do set health as the actual command itself, so /set health. And we don't really care about any aliases for this one, so we don't have to put it. So what I want to do is just add a argument, so health amount arg is equal to, sorry, I can't type. Health amount arg is equal to argument type dot integer, and we're going to call this health amount. And then now what we want this to do is basically the command will be /set health and then just an amount. And then that's going to be 1 through 20, so we'll validate that. I'll show you how to do that. So to do that, because we're using an argument, we're going to add a syntax. So add syntax, just like that. Complete the lambda here. And also make sure that you specify the argument that it should expect. Now the first thing that we want to do is extract the argument. So we're going to say new health is equal to context.get health amount arg. So we're getting that health value from the argument that was passed in. Make sure that it's 1 through 20 because that's the valid range of numbers for health in Minecraft. So we want to say if new health is less than 1 or new health is greater than 20, then we're just going to go ahead and say sender.sendMessage health must be between 1 and 20. And then we're going to go ahead and return out of this, basically this code block here so that it won't continue from there, okay? It won't run any of our logic. Or maybe we should do 0 through 20 because 0 means you're dead, so you can technically end your life if you want to, if you set it to 0. So now that we have that new health value, let's actually figure out how to set it. So sender, like I said before, is a command sender, not a player. So we want to make sure we get the command sender as a player so that we can do set health. You can't set health on like the console, for example, right? So we can do that by doing something like this. If sender instance of player. This is called instance of pattern matching. It's something that is available to new versions of Java. So yeah, it'll just check to see if sender is an instance of player. If it is, it'll give you this player variable and then, run this code block here, okay? So now we have a player object that we can work with. So we can do player.setHealth. And to this, we can pass in a float value. We can say, yeah, just pass a new health like that. And that actually reminds me, since it's a float value that it's expecting, let's change our data type from an integer to a float, just like that. And then now down here, we'll change it from an integer to a float as well. So now it should only accept decimal, float numbers, and I think that kind of makes sense for what we're trying to do here, which is perfect. And then we'll just verify that we, set the health of the player by doing health set to new health. All right, so that's all we should need for this command here, just as a recap. What we're doing here is we add the command /set health. We're defining an argument, so we're expecting a float argument called health amount. And then we're defining the syntax here based on the argument so that we can do slash set health amount, and then we're grabbing the value when they run the command, validating it to make sure it's within the correct range, and then setting the player's health after making sure that it's a player, of course. So that's what's happening here. And you may notice though that we don't have the default executor. We have not, done that like we did with the fart command here. And all that means is that if it doesn't match to any of our syntaxes, or if they do just slash set health, it won't do anything, okay? That's why you need a default executor usually, so you have some sort of fallback. But we'll go to main, and we're going to go ahead and register this. So Minecraft server dot get command manager dot register new set health command, like that. That's all we need to do. So let's go and rerun this now and test it out. All right, I'm back in the server, so we'll do slash set health, and you can see it's available to us. If we do it with no arguments, nothing happens like I just told you because there's no default executor. But if we press space, we can see that it wants a health amount as a float. So we could do 2 because, technically 2, even though it's a whole number, can be a float. So that's valid. So we've set our health to 2. So in Minecraft, basically 1, if you do the number 1, that would be half a heart. So that's why it's 1 to 20, because 20 is going to be, because 2 is a full heart. So 2 times 10, because there's 10 hearts, would be 20, all right? So we can do it again. We can set it to 20. That fixes that. We can do 19. As you can see, we can do 1. We can do 0. And boom, we died. Oh, that's funny. It says Illuminati was killed by poor programming. All right, so that's just another example of how you can create a command using Minestom. I think as good practice, though, let's go ahead and add a default executor. So set default executor, do control space. And if the default executor is run, we're going to send a message. We'll say usage slash set health amount. So this will tell them how to properly run the command because it clearly did not match to anything else, okay? So one more thing I want to show you guys is, whenever you just do, if you go up here and wherever you want to do it, if you do control space, this will give you all of the methods that are available, to this class here that is inherited from command. So we have a bunch of different things. Another cool one, though, is one called set condition. So set condition, if we do control space to complete the lambda, and basically the way that this works is whatever condition you define within here, if it's true, the command is available to the player. If it's false, it's not available to the player at all, okay? So just as a basic example here, we can do something like return sender.has permission. We'll talk about permissions in the future. Let's just say they have the set health permission. This should be false because I have not, set up any permissions or anything like that. So if we go ahead and try this out, let's see what happens. Assuming this is false, okay? If we do slash set health, it's just not available at all anymore. So that's what that can do. So whatever condition you want to put there at all, it'll check it, I believe. I'm assuming just as you join the server or something like that. And that will decide whether or not to give you access to that command or not. But if we remove that condition or just, hard code it to true even, it will be available to us again, okay? Slash set health, there we go. So you can also see the default executor working perfectly. And that's it. So that's all I'm going to show you guys about commands for now. Hopefully you guys found this video interesting. I think commands are probably the most exciting thing when learning about Minecraft development because it's cool. You can make a custom command that does whatever you want pretty much. You can add, whatever stuff to the game that you want. So now with that, you should be able to make your servers even more complex and more fun. And stay tuned for more episodes, everybody. I really appreciate all the support. Thank you, guys. Hey, what's up, guys? Welcome back to another video in the Minestom Minecraft development series. In this video, I'm going to teach you guys how to build your server to a jar file. Now, up to this point, we've learned how to make a server, how to do event listeners, how to do commands. Now I'm going to teach you guys how to actually make it so that you can build your server to a jar file. And all that simply means is taking your program and making it into a file that you can run just like any file on your computer, okay? Because currently we run the server by running it through our IDE, and that's just how we run it and test it out and all that fun stuff. But using that to actually run a server that people are going to be playing on is kind of unrealistic, right? It would be nice if we could build it to a jar file so that we could store it somewhere safe and run the server whenever we want to. So to do this, we're going to rely on the Minestom documentation. They actually have information on how to do this using Gradle. So we're going to go to your first server. I have a link for this in the description below so you can find it more easily. So scroll down to the building the server jar section. The documentation uses Gradle, so we just need to select which type of Gradle project we created with Groovy or with Kotlin. I used Kotlin, so I'm going to select that for both of these here, okay? So we want to take this piece of code here, this ID version 8.3.0. This is just a Gradle plugin that allows you to, do what we're trying to do, which is build our code into a jar file. So take that, copy it, then go back to your code and then find the build.gradle.kts file or whatever Gradle file that you have. And then go to the very top here, that's where I have mine. You want to find the plugin section and just add this as a plugin. So just add that and then click the Gradle reload button here. and this will make sure to import that plugin for you. And then come back to the documentation here, and this is all you need to get started, but to actually make it so that the jar file is runnable and all that stuff, you want to add all these other settings as well, okay? So we just want to copy this stuff here, starting from Java all the way down to tasks. Just copy this part, and then we're going to go back to our thing here and just paste it at the bottom, okay? So this is just basically telling it, as it says, that the minimum version of Java is Java 21. The jar file needs something called a manifest, which is like the information that it uses to be able to run it. And we want to point it towards where we can find the main class. So mine, if you look on the left here, is main.java. And then right here we have me.codysimpson, which is the root package of our project. So that's what it's going to be. So me.codysimpson. And then within that, we have the main class that has our main method. So whatever class you have that has the main method, make sure you add that to the end of this. So main, in my case. Something else that you can do if you want to is just remove this test stuff. We don't really care about unit testing. I'm just going to get rid of all that. We don't need any of that. And yeah, that should be good. So make sure you click the button up here again to load all the changes. So now to actually build a jar file, go to the right here and find the Gradle button. It's a little elephant. Click that, then open tasks, and then go to shadow, and then shadow jar. This is the one that you want to run here. So go ahead and right click it and do run. And now that will run it and do all the stuff. It'll compile all your code into a jar file that you can use. Okay, so it says it's done already. So let's go ahead and check it out. So you can find it by going to build, open that up, then go to libs. And here we go. So we get my first server 1.0 snapshot. That's the name of our jar file. So 1.0 snapshot is corresponding to the version that you're setting here in this Gradle file here. So anytime you update your plugin or something like that, if you want to have different versions, you can just change it here and it will be reflected in the jar file once you build it, okay? So just right click this and do open in Explorer, and this will open it in your file explorer. So now you can actually access it. You can put it somewhere safe or send it to somebody else or whatever you want to do with it. So to be able to run this file now, you can just use a terminal command. So just right click here and do open in terminal, or just open a terminal and move it to this location here. And first of all, let's check the version. We want to make sure that our Java version is at least Java 21 because that's the version that we selected. If you look in these Gradle settings again, you can see that we set Java version 21. So that is the version of Java that this program was built in. So that's the minimum version that you need, okay? So just make sure you check the version of Java that you currently have set. Because if you don't have at least 21, it won't work, okay? Very often you'll be developing with a certain version of Java like Java 21, but then when you try running it in a terminal, it won't work because stuff with environmental variables, you just need to make sure that you have the correct stuff set. One easy way that you can sort of mitigate this, if you just go to Google and search Java JDK. I don't know why my font's messed up, don't worry about that, but just search Java JDK, go to the Oracle website, and just go ahead and download the latest version of Java, the JDK. So in this case, for me, it's Java 22 at the time of recording here. Just click that, and then go to Windows or whatever machine you're using and install it. And that should automatically install the correct stuff for you and also set the environmental variable. After you do that, make sure that you close whatever terminal you have and reopen a new one so that it resets, and then check the version again by running the same command, okay? If for some reason it still doesn't show the correct version that you just installed, then you need to fix the environmental variables, and it's not too hard, just look up how to do that, okay? I have videos on that as well. But anyways, with that said, after you've made sure that you have at least Java 21, you can now run this by doing java-jar, and then the actual file name, which is my first server, and then press enter. And boom, there we go. So we're getting the logging messages, starting Minestom server, and Minestom server started successfully. So that's a good sign. So if we join the server now, it works. Sweet, just like before, same way if we run it within our IDE, or if we just run the jar file, we now have a Minecraft server running, which is really cool. The benefit now is that you can run this anywhere, anytime, on any machine. You just have to make sure that you have this jar file. You can send it to a Linux server, for example, and then if that Linux server has Java 21, it can run it. Pretty cool stuff. Once you have your server running and you want to stop it, you can terminate it by doing Control-C. That will just force close it pretty much, and then you can close this. And real quick, I want to show you guys how to make a very simple little script that you can use to run your server just by double clicking so that you don't have to open the terminal every single time. So just right click here and do new text document or whatever, and just call it start_server or whatever you want to call it, but just make sure that you change the extension to BAT, okay? And then press enter, and then click yes to change it. And now this is a Windows batch file or just a script that we can run, okay? And something else we'll do is we'll just rename this jar file to make it easier to reference. So just right click, rename, we'll call it server.jar, whatever you want to call it, doesn't matter. And now we're going to right click our new bat file and do open in Notepad or edit in Notepad. And here we just put our command that we have. So java-jar server.jar. And then Control S to save that, close it. And now to run the server, all you got to do is double click this bat file and it opens up in a terminal for you. There we go. So it's already started. It's super fast because it's Minestom. We can join. And boom, there we go. We're now on the server. Sweet. I was editing the video. I just want to add something else real quick. I showed you guys how to run this jar file within the build folder that was generated when we built this jar file, just within our projects folder. But this is not something that you want to do. This is just, for the tutorial. I also included the bat file there. Just make sure that you move this jar file into a safe place where you want your Minecraft server to be. So you know where it's always going to be. That way it doesn't get overridden or you don't lose it, okay? I just wanted to make that clear. Something else that you can do is choose how much memory you want to allocate to this Java program when you're running it, just so that you can make sure it has enough memory to do its job and run smoothly. It's probably not going to be an issue that you notice with a Minestom server when you're first developing it because it's so lightweight, but as your server gets bigger and as more people join in and stuff like that, you're going to want to worry about how much memory it has. But anyways, it's just something that you should care about. So to customize the amount of memory for the java-jar command when you're running a jar file, you can add on arguments to it. So you can do -xms. And then, for example, you could do something like 512m. And all this is saying is that whenever you start running this jar file here, initially allocate 512 megabytes of memory to this program, okay? This is your computer's RAM. And then you could also set the maximum amount of memory so it doesn't take too much on your computer. So you can do xmx, and then you can give it a size. You can do megabytes, or you can do gigabytes if you want. So let's say you want it to take a max of only 2 gigabytes. You can specify that. So what this will do when you run it is initially allocate 512 megabytes of memory of RAM to your server's program. And then if your server needs more memory, you can get it all the way up until 2 gigabytes, okay? You can customize this number to be whatever you want. Just make sure that you don't set it too high because computers only have so much RAM. For example, my computer only has 32 gigabytes, but laptops and stuff like that could have as low as 8 gigabytes or smaller, maybe 4 gigabytes. So just be careful, okay? A Minestom server should not even need that much memory to begin with. So Control S to save those changes, and then when you boot up your server, oops, I just booted up a second server. As you can see, it says it's already in use, so cancel that one. Make sure you close the one that's already running to restart it. And now we can open this again. And boom, now our server has started. Hopefully you guys learned something in this video. You should now know how to build your server program into a jar file. And then you should also know how to make a simple, Windows script to be able to run it really easily whenever you want to, okay? Hopefully this helps. Hey, what's up guys? Welcome back to another video on the Minestom Minecraft server development series. In this video, I'm going to teach you guys how to save the world and also how to use the scheduler. Up to this point, you may have realized that whenever we stop our Minestom server and we boot it back up, the world is reset, so it doesn't save anything in our world, okay? That's not good, right? Because usually you would want your world to save. Maybe sometimes you don't, but I think it's a nice thing to have. So I'm going to show you guys how you can save your world and also how to use the scheduler so that you can schedule tasks, and we'll talk more about that in a second. So to do it, you just do instance container.save chunks to storage. So that's all you got to do, but of course it doesn't make sense to call it just, within the main method like this, because basically we would start up the server, load the world, and then instantly save it. That doesn't make a lot of sense. We should probably save the world every so often as the game is going on, or when the server is stopped. And you could do all of that using the scheduler, so that's why I'm sort of combining these two concepts here. So to use the scheduler, we can do var scheduler is equal to Minecraft server.get scheduler manager. So the scheduler manager is how you can go ahead and schedule things. The first thing that we could schedule, we can do scheduler dot, and we could do build shutdown task. So as the name implies, this is a task of code that will run whenever the server shuts down, which is perfect for our use case. We want some code to run whenever the server stops. So this is asking for a runnable, and you can represent a runnable with a lambda, just like most things. So you can control space to autocomplete that, open that up, and now any code inside of here will run whenever the server is shutting down, okay? So let's start by just printing out a message. The server is shutting down. And now we'll go ahead and save our instance, so we can do instance container.save chunks to storage. And that's all you got to do. So a task is just really a piece of code, and we're going to talk more about, how to schedule tasks and stuff like that in a second. But in this case, we're using the scheduler manager from Minestom to build a shutdown task that will run this code whenever the server shuts down. And what it's doing here is saving our instance to a file so that we can load it up in the future. Everything will be saved. Okay, so let's go ahead and test this out before we do anything else, just to see what that looks like. Okay, so I'm on the server now, and the easiest way to test this is just to break a few blocks and then stop the server, And then when we come back, let's make sure that the blocks are still broken, okay? That way we'll know if it actually saved or not. So let's make a little cross there. And we'll stop the server now by just closing it here. Now I was having trouble testing this because for some reason when I stop it here, instead of going into the normal like shutdown procedure, it's canceling it and like it's basically killing it, and I don't know why it's doing that. So a way that we can test this out is just by building it to a jar file, which we learned about last episode, and then we can stop it using that and it won't, do whatever it's doing here. So that's fine. It'll just take a little more effort. So we just go here and then we want to do the shadow jar thingy. So run that task and that will build our jar file for us. I think it's good that we're doing this anyway so we can get more practice building a jar file. So once that's done, we can go here to libs and we'll open this back up. And you can see that I still have my script here. So we could use that. But of course, since we have a new jar file, we need to replace this first one here. So we can delete that one and then rename this first one or this new one to server.jar. And now we can run it. So double click and now our server is running. Perfect. And then now if we come back to here, and we go ahead and join the server, we can now make some changes to the world. We'll make another little cross thingy majiggy. Okay, and now here to stop the server, we can do Control C. You can see that it automatically stopped it. It said stopping Minestom server. The server is shutting down, which is our message that we put. The Minestom server stopped successfully. So you can Control C again to kill that. Now if you look in the same folder that the jar file was just ran, you can see that we have this world folder now, which is the world. It actually saved it. So we go inside of that, we have a region folder, and this has all the region information, just all the block information that we want to save for that world. Pretty cool. If you know anything about world saving in Minecraft, you'll notice that there's no player data or anything like that. Minestom does not save that, okay? So it only saves the actual block information about the world, nothing else. And world is just the default name for a Minecraft world. I'll show you guys how to customize the name of the world in just a minute here. So if we go and start our server back up, let's try joining again and see if our world is still there. And boom, look at that. It saved it. So that's a great sign as well. So if we just come back to the code now, I want to show you guys how you can save all the instances on the server because, currently we're just saving the instance, like just the single instance that we have, but potentially in a more advanced server, you may have multiple instances. So if you want to just get all of them and save all of them, you can. All we got to do is use the instance manager for that. So we could do instance manager, and this has all of the instances within it. So get instances, and then you could do for each since it's a list that it's giving you. And for each of the instances, you can go ahead and do instance.save chunks to storage. And then you could also simplify that if you want to. So that will do the exact same thing, except that it's doing it for each of the instances on the server that you have loaded. So it'll automatically save everything for you. That is how you can use the Minestom scheduler manager to use a build shutdown task to save the world when the server shuts down. What you can also do is have a repeating task to continually save the world. Because it doesn't necessarily make sense to only save the world when the server shuts down. Maybe that's something that you want, but with most Minecraft servers, the world is going to be saved every so often, just so that if the server crashes or anything like that and it's not able to run the shutdown logic, it can still have a recent version of the world saved on a file persistently, okay? So I think it's important to have that as well in this Minestom server that we have. And with this, we can also learn more about the scheduler manager, which is a tool you can use to build repeating tasks within your Minestom servers, okay? So we can do stuff like scheduler, dot, and you have all these methods here available to you. The first one I will teach you guys about is the build task method. This one is very simple, and as the name implies, it allows you to build a task. And again, a task is just a piece of code, a runnable, that can be repeating or not repeating, stuff like that, okay? So we're going to do scheduler.buildTask, and this is asking for another runnable, so we're going to do control space to make a lambda out of that. And within here, we can put the code that's going to run. So we're going to say saving all instances, ... And then we could use the same code that we're using up here when we shut down the server to save all of the instances on the server. And after that method, you can call more methods. So you can set a delay. You can tell it if you want to repeat it. You can set execution type. And then finally, you could call schedule. So schedule is what is actually going to schedule this task that you built here. But let's go ahead and configure some settings for it, okay? So the first thing that I want to do is do repeat. So repeat is just telling it how often you want this task to repeat. So you could do like every 30 seconds or every minute, whatever you think is necessary for whatever task you're creating. I think for something as important as saving the world, we'll do every 30 seconds, okay? So to this method, if you do Control P, you have a few different options here. You could do a task schedule, a duration, or a time in a temporal unit. If we do the bottom one, you could do a time like 30, and then I need the unit of the time, so we can do time unit dot, and you have all these units here, so seconds, milliseconds, nanoseconds, server tick, hour, day, all that stuff, okay? So we're gonna do second, and now we just have a task here that runs every 30 seconds, and yeah, it just goes on forever until you kill it, essentially. You can also add a delay. Delay is just telling it how long to wait before starting the task for the first time. So you could have the server start up, and then this code runs here, right? And then you could have it wait like 2 hours or 1 minute or 30 seconds or whatever unit of time you want to wait. And then it will go and save the world for the first time. And then every 30 seconds, it will do it again over and over and over, okay? So I'm going to set it to 1 minute. So time unit dot minute. If you want to do duration, you can. That's another option, right? So we can do duration dot, and then you have all these options here. So of milliseconds, from, of days, of hours, of minutes, nanoseconds. So you have a lot of options here as well. So I'm going to say of minutes, 1. So now we are building a task that will start after 1 minute and then repeat every 30 seconds. And yeah, now we should always have a pretty recent version of our world saved to our file system, okay? So let's go ahead and run this now. All right, so I'm going to start the server back up. I'm going to go ahead and join. And then while the server is running, I'm going to go ahead and monitor the logging messages here because we have it printing stuff. So after 1 minute, we should get the initial message of the world being saved. So I'll just wait for that. There we go. So it says saving all instances. And then now after 30 seconds, it should print out another message. There we go. Saving all instances again. And it's just going to repeat every 30 seconds. So this capability here is really cool. You can now have repeating tasks or just chunks of code that run every so often. You can configure them really nicely using this API as well. This is going to be very powerful for, all kinds of different servers that you're going to be creating because having the capability of repeating stuff over and over is pretty essential. And not even just repeating tasks. If you just want to create a task that just runs once, you could do that. You just simply remove the repeating part and then it just runs the task once after 1 minute. Stuff like that as well is very important. The documentation for this says that the scheduler manager run these tasks synchronously, not asynchronously, meaning that it should schedule them and run them on the main server thread. But with my understanding with these methods that we're calling, like save chunks to storage, it returns a completable feature, which is usually used with asynchronous operations. And we also know that Minestom was made with multi-threading in mind. So I believe, I could be wrong about this, I believe that even though these tasks themselves are scheduled on the main server thread, when it does stuff like save chunks to storage, it's going to be done asynchronously so it doesn't freeze up the server. I could be wrong, but if anyone has any more information about that, please let me know. I would love to be sure about that, okay? So using build tasks is just one way that you can create tasks using the Minestom scheduler manager. Another way is with the submit task method. So there's just two different ways pretty much. So scheduler.submit task. So in this case, we're submitting a task. So it's asking for a supplier, which is kind of similar to the runnable that we're using above, except that it expects a return of task schedule. So let me show you what I mean by that. So control space to autocomplete, open that up. And then now we could, just have like normal, just the code that we're going to run in this task. So I'm just going to say peanut butter. And then the return is just the actual settings for this task here. So instead of using the builder and building it using a method here, or methods, you just return it with the information that you want to use. So you could do task schedule dot, and then you could tell it the schedule or how often you want to repeat this task, okay? For example, you could do duration, and then you could set a duration by doing like 20, and you have all these different options here as we saw before. And I'm going to show you guys server tick. So a tick in Minecraft is the unit of time that Minecraft uses. 1 tick is equal to 1/20th of a second, but an easy way to think about this is that 1 second is equal to 20 ticks. Luckily, Minestom seems to make it easier for you because we're dealing with, instead of ticks here, we're dealing with, you could specify a duration of any unit of time, which is really cool, or time unit. But in other APIs like Bucket or Spigot, for example, it likes to use ticks exclusively, so you have to know what ticks are. But I think even though they make it easy for you when scheduling these tasks here, you should also know what a tick is just for the future and in general if you're going to become a Minecraft server developer. So again, a tick is just a unit of time for Minecraft servers. The server keeps ticking, and 1 second is equal to 20 ticks, okay? So right here, since I set the duration to 20 ticks, this means that this is a task that will repeat every single second, okay? So let's go ahead and see what that looks like. I'm just going to go ahead and run it. just back in the IDE since that's easier and faster. Let me go ahead and, oh, I need to make sure that I stop the server that's running in my console, right? So just kill that. And then now go back and restart it here. If you just check the console here, you can see that it's printing out peanut butter over and over and over every single second. So it's working perfectly. There's so many methods you can call upon the scheduler manager, but one other one that I want to show you is schedule next tick. And this is just a way of making a task that runs, in the next tick, okay? It's pretty self-explanatory. So if you just open that up, complete the Lambda, this code here will print out, that message on the next tick, all right? This one's not repeating though. It's not going to run like every single tick. This is just a way of scheduling something for the next tick. So you can see that it printed right there as soon as we restarted the server. And that's pretty much it. That's how you can schedule tasks using the scheduler manager. Very important thing, like I said, that we'll be using in the future. Another thing that is really important that you can do is whenever you build these tasks or you call submit task or whatever, usually it's going to return a task for you to store in a variable. So we could do something like var task is equal to that. Same for this one. So var task 2 is equal to that. And this is just a way of taking this task that could be currently running on your server or about to be run in the future and giving it to you as a variable so that you can cancel it if you want to or just get information about it. So we can do task dot, and we have a few methods here like cancel. That's probably the most important one because at some point you don't usually want these tasks to run forever, right? Except for maybe the one that is going to save the world, but for the most part you probably don't want them to run forever. So at some point you want to cancel them. So that's how you would do that. You can also see if they're still alive and the owner of it and stuff like that. So just knowing that you can have it as a task object is pretty cool. And that's all I want to show you guys for scheduling. The last thing I want to show you guys is how you can specify a name for the world, a custom name for the world. So currently when we create our world as a instance, we're using, the instance manager to do instance manager.create instance container, and we pass nothing into this. But if you want to, you could do new anvil loader. This is just the default one that is used by Minestom, but you can provide your own in the future. Once we get into more advanced world generation, you could provide your own loader if you want to, or someone else's loader. But what you can see here is that if you do new loader and pass that into create instance container, you can also specify the path of where the world is going to be. So let's just say that we do potato. This will basically say that whenever the server starts up, it will try to find the folder with the name potato and just whatever directory this is running in. So in this case, the jar file that we had was running just, here. So that's why I put the world here. And if it can find it, then that's the world that will be loaded into your server when it starts it as this instance container. If it cannot find the world, it will create the folder for you when you save the world, okay? So for example, I currently do not have a folder named potato. I have no world named potato. So when I start the server up, it's going to create one in memory, right? But then when I call save chunks to storage, it will save that world as a folder named potato. Okay, hopefully that makes sense. That is why we have this world folder here, because that's the default world name, as well as the path. We don't have to have it in the same directory as the jar file. That's just probably customary. You could have it in a subfolder like, maybe something like worlds, and that should save in a subfolder called worlds. And yeah, that's just a simple way that you can customize the world name if you want to do that, okay? That's also important if you want to have multiple worlds or multiple instances. If you load multiple, obviously you need to have different names for each of the different ones. So that's important to know how to do, okay? And yeah, that's it for this video, everybody. I really appreciate all the support, like I said before. And hopefully you guys learned something new in this episode. I think the scheduler manager within Minestom is really easy to use and it's pretty awesome. So now you guys should know how to save your world and also schedule tasks and all that fun stuff, okay? Thanks for watching, everybody. Hey, what's up guys? Welcome back to another video in the Minestom Minecraft server development series. In this video, I'm going to teach you guys how to use the adventure library. Welcome back, everybody. So according to the adventure documentation itself, adventure is a library for server controllable user interface elements in Minecraft Java Edition. Now the user interface elements it's talking about is stuff like messages, titles, boss bar, sound, books, the player tab list, all kinds of stuff like that you would usually send to a player or other stuff on the server. Adventure allows you to create and send these elements in an easy way, and also just in a way that makes the experience generally better than you would have to do otherwise. Adventure is not something that is unique to Minestom. It's actually an external third-party library that Minestom has included into Minestom just because it's so cool. So this official adventure documentation is separate from Minestom, and I'll have a link for this in the description below so you can check it out yourself. This teaches you basically how to use it, and all the different concepts involved in adventure. So in this video, I'm going to focus specifically on sending messages and titles. but also just how to use the adventure library and how to use audiences and stuff like that, what they are. There's a lot more things, of course, that I could show you, but we'll learn more about that later in the series. But also, just learning these basics here will allow you to learn those other things really easily because the same concepts apply, okay? To test this out, we're just going to add some code to our event handler for the player block break event that we did before, so that every time they break a block, it'll send them a message, and we could, play around with how that message appears. If we want to send a player who broke a block a message, we can do event dot get player, and then now that we have a player, we can do dot send message. And you can see that there's a lot of different versions of this method here. One of them accepts just a string, so you just pass in like a regular string, and that will be sent to the player as a message. Or you can do a component. So we can create a component by doing component dot, and if you scroll down, you'll see a bunch of ones involving text. So component.text will allow you to create a text component. So we just go ahead and type text and press tab to complete that. Now we can provide our text inside of here. So we could say, hello, this is a test, or actually we'll say, you just broke a block. So this is our text. So what we have done here is created a component that has text within it, and now we're just going to send that component to the player. What's cool about this is that now that it's a component instead of just a string, you can build upon it, add formatting and colors and other advanced features, but we'll see that in a second. For now, let's just go ahead and start the server and see if this works. All right, I'm on the server now, so we can test it out by breaking a block. And boom, it says you just broke a block. Coming back to the code here, one thing that we could do is add some color to this. So within the .text method, we have also different overloaded versions of this. So you have style, text color, all kinds of stuff here. Text decoration, for example. Let's focus on text color. So text color. And for this, you can do text color dot, and you have these different options here. So you can provide color in different ways, like an HSV value, RGB. You could also do a CSS hex string, so hexadecimal. Pretty cool. Or if you want to, if you just want to do like a normal, like default Minecraft color, you can do named text color dot, and then here's all the default Minecraft colors. So you have gray, aqua, black, blue, and so on. So let's just do aqua. That's one of my favorite colors. So now what we have here is a text component that has some text within it, but it should be colored aqua. So let's try this out. Okay, break a block. And boom, it says you just broke a block, but now it's aqua colored, so that works perfectly. What you can do is actually just take all of this, Control X, cut that, and just extrapolate that into a variable. So var message is equal to component.text. And now you can add more stuff onto this. So if you want to, you could also do dot color and do the same exact thing. If you want to provide named text color dot aqua, you can do that, and then you get rid of this one. You can also do decoration. So decoration is stuff like, let me just show you. We can do text, decoration. And now we have these options here like bold, italic, obfuscated, underline, and strike through. So let's go ahead and do bold. You can actually do more than one. So text decoration dot underline. So now we should get a aqua message that is bold and underlined. Let's just change this to red actually. So now it should be red. And then now we just got to pass our component variable into that, and it should send it to us. So now we can break a block. Boom, there we go. We get you just broke a block in red and underlined and also bold. So that's working. So as you can see, it's pretty simple to be able to build messages or text components using Adventure, and then add on, formatting and stuff like that using these methods here. You have stuff like append a new line if you want to. That's, again, pretty self-explanatory. You'll append a new line. And then you could append even more components onto this. Even though you just started with one text component, you can add as many components as you want to create even longer, a more complex message. So we can add another text component by doing component.text. And into this, we can pass another message like, let's just tell them what block they just broke. So we could say you got, and then we'll add on the material.name. So this will be our original message. And then we're going to add a new line to that. And then we're going to add another piece of text that says you got, and then the material name for the block that you just broke. There we go. So it says you just broke a block. You got Minecraft grass block. So let's make this look a little cooler. So we're going to take the material name, cut that, and we're going to add on another text component. So append component.text, paste that in, and then we'll set the color for that. So color named text color.gold. We can fix the formatting by doing Control-Alt-L. You can also just do this because it's kind of hard to tell at some point which one you're referring to. So we have this component here. We have a text component which has the material name, and then we're adding the color onto it. And we could also add some decoration if we want to. So we could do text decoration, italic, and text decoration underlined. And then we'll just get rid of this decoration up here. We don't really want that anymore. So now we have appended this other component here with the color and decoration. And since it's sort of nested like this, it should only apply to this one and not the whole thing. So this one's red, and as you saw, the red transferred over to this part here. So we can add a color for this one as well. We could do text color dot, and you could do RGB or whatever like I showed you before, or you can do like a hexadecimal string. So if you just search up on Google color picker, this is what that would give you. So we can just play around with this and choose any color that we want, like pink. And so this would be the hex string that we could Control-C copy, come back here, and then paste. And it's just complaining because I put it in the wrong place. So just like that. What's cool is that IntelliJ also realized that you're using a color here, so it's able to display that color for you, which you can click on and change even, which is pretty cool. Let me undo that. So let's try this out, see what this looks like now. Okay, we're back on the server. Let's break a block. And boom, it says you just broke a block. You got Minecraft grass block. So as you can see, all the colors and formatting and stuff like that is being applied. Pretty cool. Hopefully this is making sense so far. This is just basics on how you can do text components with Adventure, because these components are useful for not only sending messages, but also other types of elements that you send to a player or on the server, like titles and stuff like that. Knowing how to build these components here is very important. Another thing that you can do with Adventure is hover and click events. So for example, you can do hover event, and then to this you pass something called the hover event source. This can be something like a text component or an item stack. And all this means is that whenever you hover over this text component here, which is the material name in this case, it will show that thing that you pass into this because you're hovering over it. If you use the click event instead, whenever you click the message, then something will happen instead. Just as an example here for the hover event, we're going to set component.text, and we're going to say hovering over the item. So that should be displayed whenever we hover over. Let's try it out. Okay, we're back. And boom, you got same message as before, but now when we hover over the material name, it says hovering over the item. So if you've ever wondered how you can do that, that's how you can do that really easily with Adventure. And yeah, that's pretty much all I want to show you for the basics of building text components within Adventure. Again, check their documentation for more information and more stuff that you can do, but these are pretty much the main common things that you'll need to be able to do. And we're sending it to a player by doing player.sendMessage. So this is returning a player object, and then we're doing send message, right? And the thing about the player object is that it's also an audience, meaning that it can receive stuff from Adventure, basically. So Adventure is not only about building these UI elements, but it also has something called audiences within it. So an audience in Adventure, as the documentation says, is a grouping of 0 or more viewers of some content. And all that means is that anything that is an audience, such as a player, for example, can receive these UI elements that Adventure has. In Minestom specifically, audiences include players, command sender. So whenever you're dealing with commands, the sender of the command is also an audience, so you can send them these components as well, and also other things. Scoreboards and teams and stuff like that, and also the instance. So for example, we know that an instance is a world in Minestom, right? So if you do instance and then do .sendMessage, that is a valid method on a instance object, and this is because it is an audience, right? And so whenever you do send message to an instance, this will forward every single person in that instance in the world the message that you're trying to send, okay? And that's a really cool abstraction by Adventure because it has this, audience thing that could technically be anything. And as long as it implements audience, you can send it these sort of universal UI elements such as messages and titles and boss bars and stuff like that. And I'll talk more about that in a second, but just for now, know that because a player, which we're getting here, is an audience, we're able to call a send message and pass in that text component from Adventure, okay? With that in mind, one of the other things that you can send it to an audience member is a title. So a title, if you've ever seen it, I'll show it on the screen right now. That's what a title looks like in Minecraft. So what I'm going to do is make a simple command that we can use to test that out. So we're just going to call this the title command. So title command. And so remember from the commands episode, to make a command, you do extends command from Minestom. And then we need to make a constructor. So we'll do public title command and then do super. And now this will be the command name. So we're going to call it title. And inside of here, we can also declare the syntax for the command as well. We're going to add a very basic default executor so that if there's no arguments or anything like that, this is what will run. And so for this default executor, we have sender and context. Remember, I told you before that a command sender, which is what this is an audience as well. So this means that we can do stuff like sender.sendMessage. And you can see that it accepts a component from Adventure. You could also do something like show title or show boss bar, which are from Adventure as well. So show title is what we're going to be focusing on, and what we pass to that is a title. To create a title, we can do title is equal to title. Now you can provide the title as a component and also the subtitle as a component. So let's just say that we want the top part of it to be hello world in like gold, for example. So what we can do here is make a component, a text component, and we'll say hello world. And then to make it gold, we can, as we saw before, do color gold, or we could just do comma named text color.gold, either way. So that's going to be for the main title, and then for the subtitle, we can add another component for that as well. So I'm just going to go ahead and copy this first one here, paste it, and we'll say for the subtitle goes here, and we'll just make this one gray. And also we'll add some decoration. We'll do text decoration italic. So the subtitle should appear with italics, but not the actual main title, okay? Because these are two different text components, right? If you want to, you could separate these into variables, especially as they get more complex. So you could say main title is equal to that, and then var subtitle is equal to the bottom one here, just like that. And then now we can pass them in like main title and subtitle. Okay, now that we're using this main title and subtitle to create a title, we can pass this title into show title, which will show it to this audience member, which in this case is the person who ran the command sender. Before we can test this out, we need to register our new command here. So we'll go back to here and we'll do Minecraft server.get command manager.register, and we'll pass in new title command just like that. So now it's going to restart the server and test it out. All right, back on the server now, so we can do /title. Boom, it says hello world in gold, and then the subtitle in gray and also italics. So it works perfectly. Pretty awesome, right? And you can do the same thing for boss bars and other stuff like that, like even sound, right? As long as you have an audience member, you can send it stuff like that using Adventure. And it's so easy to craft the actual components of the title, like the main title and the subtitle, just using the components that we already learned about. So the same way that we can create text components for messages, we can create text components for titles as well. If we want to get more practice with commands, we can also make this more advanced by making it so that they can pass in the actual main title and subtitle to this. So what I'm going to do is do var title text arg is equal to argument type dot string. So we want a string, which is going to be the actual title text. We'll say title text, and then we'll do var subtitle text arg is equal to argument type dot string subtitle text, just like that. And then now we're going to add a syntax for that specific variation of this command here. So add the comma, title text arg, and then subtitle text arg. So now this will be like /title, title text, and subtitle text. So for the actual code of this, we can first get those values. So we'll say title string is equal to context.get title text arg, just like that. Same thing for the subtitle. So subtitle string is equal to context.get subtitle text arg. And then finally, with all of that, we can now construct an actual title to show to the player who ran the command. So we're going to do title, we'll say new title because we already have title above, and we can go ahead and do title, and then we can pass in components for that. So we'll do component.text, and we'll do title string, and then we could do component.text subtitle string, and there we go. So and then after that, finally, we could use our sender, which is an audience. So sender.send, or rather show title, new title. So that should show it to that command sender. So hopefully that makes sense. We're simply adding these two arguments for the main title and the subtitle. When they run the command with this variation here with those two values, it should pass those in and use that to create the title to show to the command sender, okay? Let's try this out. All right, we're back, so we'll do /title. So this still works the same, but now if we put a space, we can see that we have title text and subtitle text. So we can say potato and banana, and boom, there we go, potato and banana. So it's able to take those arguments and then construct a title dynamically and show it to the player. So something else about titles is that you may want to customize the time in which they're shown on the screen for the audience member. So this time is going to be broken up into 3 different sections. You're going to have the 1 is going to be the fade in time, 2 will be the display time, and then 3 will be the fade out time. So as these names imply here, the fade in time is how long it takes for the title to actually fade in. The display time is how long it's going to stay faded in, just stay solid and just on the screen. And then after that's done, the fade out time is going to be how long it takes for it to actually fade out to be completely gone. We can set that by doing var title times is equal to title.times. So title.times.times. And here we can see the duration for the fade in, the stay, and the fade out. So we already know about duration from the last episode, so we can do duration dot. We have all these different options here, so we could say between, from, of days, of hours, of milliseconds, of minutes. So I think of seconds is probably the most useful one, or milliseconds. So duration dot of seconds, we'll say it takes 2 seconds to fade in. We'll say it takes 3 seconds to stay. And then for the fade out, we'll do duration dot of seconds, or we can do milliseconds just as an example here. Let's just say 500 milliseconds. So it should be half a second, which is pretty quick. Now that we have this variable here, which sets each of these 3 times here, we can set this when we're creating the title itself. So here when we do title.title, the last argument we could pass to this, which is optional, is the title times. There we go. So now when we run /title, it should show it for these durations, okay? Let's try it out. Okay, we're back on the server now, so we'll do /title. So it took about 2 seconds to fade in. Now it should be 3 seconds to stay, I believe. And then it faded out pretty quickly, as you saw. So you can play around with those times, make it as fast or as slow as you want. Since we use duration, it makes it pretty easy to do all of that. So that's pretty awesome. And yeah, that's the basics of how you can send titles using the Adventure library. It's again very easy, just using the text components and all that fun stuff. This is yet just another benefit of using Adventure, considering how easy it is to make these titles and also send them to different audience members. I want to show you guys how to create one more command, which will also show more about audiences in general, so that we can get a better understanding of how we can get audiences and what they are. So let's go ahead and create a new Java class called the broadcast command. So broadcast command. This will allow us to broadcast a message to a audience of people. So extends command. We'll do public broadcast command super broadcast. So that's the name of the command. And the way we want this command to work is we want the player to be able to do /broadcast and then pass in a message. And this message here can be not only just one string, but as many arguments as they want. So it could be something like I like spaghetti, spaghetti, spaghetti. So this is, as you can see, 3 different arguments, but we want to have it combined together and then broadcast it to all the players on the server, for example. So first step, let's just add a default executor. So set default executor. And we're going to say sender.send message. You need to specify a message to broadcast. So /broadcast message, just like that. As you can see here, we're just using a string and not a adventure component because we're not doing any formatting or any coloring or anything special like that. So that's just why I did it like that in this specific example here. You don't always have to use components. So now let's define the syntax that will allow us to pass in these arguments here. So we're going to do var message arg is equal to argument type dot string. Instead of string, we're going to do string array. And this is just an argument type that allows us to specify or grab multiple arguments together as a single string array, okay? So let's just take a look at what that looks like. So we'll do message, and then now we're going to add a syntax, complete the lambda, and we're going to add our argument to that syntax. So message arg. And now to actually grab those arguments when you run the command, we can do string array instead of just a regular string. Message array is equal to context.get message arg, just like that. And just like you might expect, what this will do, since we specified it as a string array for the argument type, whenever you run the command with arguments, it will take each of the strings and combine them together into the string array here, with each element being an individual argument or word or whatever you want to call it, okay? So now what we should do is combine that together into one single message. An easy way to do that is using a string builder. So string builder message builder is equal to new string builder. And then we could do a for loop. So for string s out of the message array. So we're looping through that string array. And then for each element of that array, we can do message builder dot append s dot append space. Just add a space onto the end of that. And then now we have the final message. So string final message is equal to the builder dot toString. So this is taking everything that we added to the builder and then converting it into just a regular final string with everything all together, okay? So now what we need to do is send the message to all players. Now in different frameworks, you may have to get the server and then get every single player in the server as like a list or something like that, and then loop through the list and send each message one by one. But since we're using the Adventure library, which is built into Minestom, we can just do audiences from Minestom dot, and we have these different methods here that will give us an audience. So first we have players, and what this will do is give you every single player on the server as an audience. And so since we have all these different things here as an audience, we can call, show title, send message, and all that stuff, and it will send it to all of them automatically for us. We also have server, which is similar to players, but it will also get the console as well. So it's a combination of all the players on the server and the console. You have all, so this will get all audience members. This returns players combined with customs and console. And then you have custom. So yeah, custom is basically just a way of creating custom audience members, which we'll learn about in a future video. This will be a more advanced topic. So the main ones that we're going to work with is going to be players, server, and console. There's also variations of these that accepts a predicate. So basically you can have it get every single player who matches this filter here as an audience. So I'll show that in a second, but that's really cool stuff if you understand what I'm saying here. So the first thing that we'll test out is just players. So we'll do audiences.players, which again gets every single player as an audience. And then we could do send message, because again, anything that's an audience, we can do send message or show tile or show boss bar, send sound or anything like that, okay? And now it's going to want a component, so we'll do component.text, pass in that final message. And we can even add some color to it if you want to. So named color, we'll do green. Let's go ahead and test this out now. So we just need to make sure that we register our command here. So Minecraft server.get command manager.register new broadcast command. Okay, I'm joining back now. We'll test it out. So do /broadcast. Oh, I spelled broadcast wrong. Hopefully you guys noticed that, but broadcast. And it says you need to specify a message to broadcast, which is our default executor. But now if we do space, we can pass in a message. So we could say, I really like toes. So now it says, I really like toes. And as you can see here, I got it as a message in green, which is perfect because that's the names color that we set for that when we, ran the command here and sent the message. And also keep in mind that because we're doing audiences.players, this should have been sent to every single player on the server. But of course, since I'm testing this just on my computer here, and I only have one account at the moment, I'm only going to notice it. So if you do have other accounts who can join your local server, you can also test it out that way as well, okay? But yeah, just knowing that you can do audiences dot, and you have these different options here to obtain an audience is very important. But there's other ways to get audiences besides that. You can get audiences from, like we saw before, with the command sender, with a player. So like if you're doing an event, for example, you can get the player from that event, which is an audience as well. And let me give you an example of the players method here with the predicate. So if we add this, a predicate is again just a lambda that returns a true or false, basically, that will filter out different options. So we could say something like return player dot get game mode, and we could say if the player is in survival, return true. And so this will basically make it so that it returns an audience that only has players that are in survival. That's all that will do, okay? Okay, we'll do /broadcast wiener. There we go, we get wiener. So because we're in survival, that works. And of course, we can also do all. So this will get every single person on the server, like all the players, but also the console and the custom ones that you add. Something else that I find really cool is that an instance is also an audience. So if we just get rid of this and we do if sender, because sender is a command sender, we want to make sure it's an instance of a player. So player like that, import player from Minestom. If it's a player, we can now do get instance. So we're getting the world or the instance that the player who ran the command is a part of. And since instance is a audience, you can now do the adventure commands. So send message or show title, just like any of the audiences that I just showed you 2 seconds ago. But what's cool is that because it's an instance, when you run send message on this or whatever, it will send it to every single player who's in that instance automatically. So I just think that's really cool. That's the kind of like built-in functionality that Minestom has integrated with the adventure library that just makes the whole experience better, because normally you would have to, in a different framework, get the world or the instance, get all the players in the world into a list, like I said before, and then send the message one by one. In this case, we don't have to do that, which is pretty cool. And so we can do component.text final message, and it should still work. So say broadcast bello, and it still works. Perfect. And yeah, that's pretty much all I wanted to show you guys for this episode. This is how you can use the adventure library within Minestom, which is very important for learning how to send messages, first of all, so you can send, formatted messages with color and decoration and other cool things built in. But also, besides sending those messages, we learned about text components, how to build those text components and add all kinds of cool stuff to them, which we can also use to show titles as well. Finally, we learned about audiences, which is an easy way to send these UI components like messages and whatnot 2 players on the server. Overall, it makes the whole process way easier than otherwise. So hopefully you found this video interesting, and now you should be able to make your server even more advanced. So thanks for watching, everybody. I will see you guys in the next episode. Stay tuned for more videos. Hey, what's up, guys? Welcome back to another video in the Minestom Minecraft server development series. In this video, I'm going to teach you about blocks. What I'll be doing is teaching you guys the fundamentals of placing blocks and just working with blocks in general, how to configure them and how to get information from them. It's all pretty easy, so this should be a short video. To actually test this out, we're going to make a new event listener for the player interact block event, which is going to be triggered whenever someone right clicks a block. That way we can make it so that when someone right clicks a block in our world, we transform that block into a new block. And with that, we can learn how blocks work, okay? So we're going to do global event handler.add listener. We're going to do player block interact event.class. Then we're going to make a lambda, and I'm just going to go ahead and rename this to event. And so if we do event dot, we have all this different information here, like the block that was interacted with, the player, the position of the block that was interacted with, the instance, so what world that block was in or what instance, the block face, the cursor position, the hand, and all that stuff, okay? All pretty useful information. So we're going to start with the hand, so get hand. We're going to say if event.getHand is equal to hand, which is an enum, hand.main. You have main and also off. These are your main hand and off hand. So we're going to do main. So if they interact using their main hand or right click using their main hand, this will be true. And we'll just send them a message to test it out. So we'll do event.getPlayer.sendMessage. You interacted with a block. I think at this point in the series, this should be simple enough to understand. So we're just making a new event handler here for the player block interact event. And we're checking to see whenever the event is triggered, if the hand that was used for the interaction was the player's main hand, and then if it is, we're going to send the player a message, okay? So let's just run this and build the server and jump on the server and test it out. All right, I'm back on the server now. So to test this out, we just need to go up to any block and right click it, and boom, it says you interacted with the block. If I left click, that does not trigger the event. That's only if I right click, but it's also using my main hand. So this little hand that I've got shown here, I don't even know how to switch to my offhand anyway. I've never really done that, so anyways, it works, which is good. So now let's try working with a block. So the first thing that we could do is extract information from blocks. So this event itself has to do with, player interacting with blocks. So we can get the block from that by doing event.getBlock. And this returns a block, so we can store that in a variable. So var block is equal to event.getBlock. So with this block, you can do block and do dot, and now you see all these different methods here. So you can get information about the block just generally, if it's air, if it's liquid, if it's solid, a namespace, possible states, properties, stuff like that. So properties we'll talk about in a second, but you'll also get a lot of information from the registry. So the registry contains information about the current block. So if you do registry, that's a method, and then you can do dot on that. And then you can get other important information like the material. This is probably the most important thing that you'll ever need from a block. This is just the actual material itself, like a grass block, a wooden door, or an oak door, stuff like that. Those are all controlled by materials. All of the different items and blocks in the game all have a material behind the scenes that you represent it with. So this is how you can get the material of the current block by doing block.registry.material. You can also get the block entity, the ID, is it a block entity, collision shape, friction, hardness, is air, is liquid, all kinds of information, is solid, occludes. Yeah, so just whenever you need information about a block, the registry is a good place to get that information, okay? Something that you'll notice though is that there's not really a way to get the location of the block just by these methods here. So in this case, since we have the player interact event, we can do event.getBlockPosition, and that's how you would get the position of the block in this certain instance, okay? This returns a block vector, which is just the XYZ coordinates of the block pretty much. So you can get the block X, Y, and Z. But I think what you really want to see is how to modify the world or the instance, and then also create blocks. So creating blocks. So to test this out, what we're going to do is make it so that whatever block you right click, we're going to turn that into a whole nother block, okay? So to create a block, we just need to get an instance of it. So we could do var new block is equal to, and then we could do block, which is from Minestom. So net.minestom.server.instance.block dot, and then you have all the blocks in the game. So every single block in the game should be here. So you just need to find whatever block you want to put. Let's do a crafting table, for example. Crafting table. So this little variable that we have here stores a reference to the crafting table block, which we can now use. So we can start by getting the instance. So event.getInstance. So this is the instance that the event happened in, where the block was right-clicked. Dot. And then we could do set block. So this is how you can modify a specific block in that instance. And as you can see here, all you have to do is tell it where to put that block, and it will put it for you. So XYZ, which is the coordinates, and then the actual block itself. Or you can also do a point object. And if we do just event.get block position, this inherits from point. So this will work as a valid location. So whatever block we just right clicked to trigger this event here, this will get the location of that block. We're passing it into set block. And then now we can pass in a new block. So that will replace the current block in that position with this new block that we have, which in this case is a crafting table. And that's it. That's all we got to do. Let's try it out. Okay, back on the server now, so we can right click blocks, and look at that. Every single block that we right click turns into a crafting table, just as we expect. Because what it does is, again, every time you right click a block, that triggers the player interact block event, which will then get the instance that this happened in, and then set that position where the block was clicked into a new block, which is a crafting table. So pretty cool. And as you can see, it's pretty simple to do this. All you have to do is call instance.setBlock and then pass in the block. And then actually getting the block is so easy itself. You just do block dot and then whatever the block is that you're trying to set it to. Now the thing is, you may not want the default state of whatever block you're trying to set. Sometimes you want something a little more advanced. So for example, let's say that you have a door block. So you could do something like oak door. And you want to make it so that the door is open by default or the door is facing a specific direction. What you could do for that is set the property of the block. So after you do block dot and then whatever the block is, you can do dot with property, or you can do multiple at once, but with property, and you can specify the property that you're trying to set along with the value. And so the question is, since this is just taking a random string here, how do you know what properties you can set for these blocks here? And I'll have a link for this in the description below, but this is the Minecraft documentation. And this has the documentation for block states, which is also known as block properties. So these are all the different blocks in the game along with their properties that you can set on those blocks, which is pretty freaking awesome. So you have all kinds of stuff like dirt, for example, if it's normal dirt or coarse dirt. So for example, these are the different properties for a redstone repeater. You have the delay, which by default is 1, but you also have 2, 3, 4. So this is the redstone repeater's delay and redstone ticks. You have what direction it's facing. So by default it's north, but it can be east, south, or west. Yeah, it gives you information on what that means, if it's locked or not, if it's powered or not. Pretty freaking cool. So you have same thing for redstone torch, if it's lit or not. So basically anytime you want to place down a block with more advanced properties, all you need to do is just know what property to set. You can refer to the documentation here, and then you can set it using with property. So if we go back, so the block that we have here is the oak door, right? So if we come back to the documentation, let's just find door. So right here, doors. So for doors, we have a bunch of different properties. We have facing, so what direction the door is facing. You can also specify the half of the door that is placed. So you can place just the lower part of the door or the upper part of the door, which is interesting. You can specify the hinge if it's on the left side or the right side. Let's try this out. So we're going to do the half property, so half. And then the only values for that is upper and lower. So we're going to try upper. And let's just see what that looks like when we place the door. So we came back on the server now. So if I right click a block, look at that. I only get the upper part of a door, which looks weird. But that's because we have modified the default state of our block that we're placing so that it's basically telling it to put only the upper half. So that is what properties can do for you. This is just one example here using doors, but you can imagine that any block that has any sort of complexity to it, you can modify using these state properties, okay? And it's pretty easy to figure out. You just got to refer to the documentation. Let me give you guys one more example here. So another one I want to show you is the sweet berry bush. Sweet berry bush. For this one, I think this one's pretty cool. So you have the age of the sweet berry bush. So it starts at 0, but you can have 0, 1, 2, or 3. 0, it means it's a young plant. 1 means no berries. 2 means some berries. Using the bush gives 1 to 2 sweet berries and sets the age back to 1. And then 3 is full berries. Using the bush gives 2 to 3 sweet berries and set the age back to 1. So we can play with, when placing our sweet berry bush, setting the age of the bush, which is kind of cool. The default age of the sweet berry bush when we place it is going to be 0 normally, but we can sort of override that behavior and set it to 2 just by setting the property when we create it. So we can do sweet berry bush, so that'll give us a block that represents the sweet berry bush. And then we could do the age and set the age to 2. Even though that's technically a number, it wants it as a string, so we're going to provide it as a string, okay? Let's try this out now. Okay, back on the server, so if we right-click these blocks here, you can see that it's putting these sweet berry bushes. And then if we come back to our code and set it to 0, it should put only baby ones, like that. There we go. So we're only getting baby sweet berry bushes now, so that's just yet another example of modifying the block state of a block by using the with property method and specifying the property that you want to set it. Pretty cool stuff, right? Another cool thing that you can do with blocks is set a custom handler to it. So you can do with handler, and to this you can pass in a block handler. And basically what this is a custom event handler specifically for this block or whatever block you give it to. So what we're going to do is go back to our file thingy here and make a new package just called handlers. Okay, and we're going to make a new Java class called we'll just call it test handler because it's not really going to do anything too crazy. We're just going to test this feature out. And we want to go ahead and do implements block handler from Minestom. And now we can click this and do Alt Enter to autocomplete, or you can just hover over it and do implement methods. And what you need to do is implement at least one of these methods, which is the get namespace ID, but you also can choose these different methods here to override. So basically, these are going to be your event listeners for this specific block here. So every single time you, for example, place this block here, this will be triggered, and you can listen to that and then handle that in different ways. You also have on destroy, on interact, on touch, all very cool stuff. So let's test out on place and on destroy. So you can hold control to select multiple of these here and then click OK. And we have to modify this namespace ID here to just give it a unique identifier so that it can be, uniquely identified. So we can do namespace ID from Minestom utils dot from, and now you just want to give it a unique identifier. I'm sure people will do this in different ways, but I think a good rule of thumb here is just have the name of your, I guess your server, whatever you're calling this, application here, as the first part of it. So we could do like Minestom tutorial for me. So Minestom tutorial and then a colon, and then give it the name of the handler itself. So test handler. Or maybe you can put the name of like yourself, like my game name is Illuminati. It doesn't really matter what you put, just try and make it unique so that it doesn't conflict with other namespaces on your server. But yeah, once you have your namespace ID to identify this handler that we have here, we can now modify these methods here to actually handle different situations. So again, this is going to be on place. So this will be triggered whenever a block that has this handler is put down, or placed rather, right? So with placement, we could do like placement dot, and we have all this information here like get block, get instance, get block position. You can think of this as the events that we would normally have with our global event handler. So usually have like event like this. This is kind of a similar concept. With it, you can get information about the event that happened. As a simple test here, we could do something like sout test block placed at, and then we could do the block position. So placement dot get block position, and hopefully that should convert it to a string automatically for us. We'll leave this one just for a second here, but once you have your block handler created, you can now assign it to different blocks that you have on the server. So for example, our new block that we have here, we can assign that block test handler to it. We can do that by doing new test handler, just like that. And now since it has been assigned that block handler, whenever we place this block, it will, print out this message, okay? Let's try this out. Okay, back on the server now, so let's try this out. So boom, you interacted with a block. So still placing those blocks same as before, but if we check the console, it prints the message. So it says test block placed at, and then we have all these different coordinates here. So it's able to actually detect and handle the block placement as we would expect, since we've assigned it as a handler to our new block here for the sweetberry bush. I don't know about you guys, but I think that's pretty cool. I've never seen anything like this before. So previously we could just make, regular event listeners and assign them to nodes and stuff like that, or the global event handler to handle stuff like the player block interact event. But now we can not only do that, but also assign handlers to specific blocks, which is just really cool. So, placing, destroying, interacting, other things can be handled directly on the block on a block by block basis. Basically, we can handle them per block, which is crazy. And if you just think about this further, you can give different handlers to different blocks, and blocks can even share the same handler. So if I had just another block here, for example, if I just had my door again, so my oak door, just like that, I could give it a new instance of test handler if I want to, or I could just take it, make this into a variable test handler like that, and then pass that into both of these. And now both of these blocks, even though they're different, even though these are two different blocks, share the same handler. So the same code, so the same exact code from the same exact instance will be handled whenever that block is placed or whatever you're handling, okay? Anyway, so I could also go ahead and handle the on destroy for this block here. So whenever this block is broken, one thing that you can do is, since this is just destroy, doesn't have a lot of information about who placed the block, or rather destroyed the block. One thing that you can do actually is do if a destroy that we have is a instance of player destroy. That's how you know if a player destroyed the block. So that's how they chose to design that. So if it's a player destroy, then you know that you can do player destroy dot get player. So that's how you would get that information. So let's get the player, and then we can send them a message saying something like, you broke the test block. Just as an example, let's say that, something happens on the server and the block is broken. This would only run if a player directly broke the block, not if like TNT exploded or something like that and the block broke. So that's why that might be useful. Okay, we're back on the server. Now we can break these, and it says you broke the test block. So it's working how we might expect. Perfect. And that's pretty much all I wanted to show you guys about, working with blocks and placing blocks and setting properties and handlers and stuff like that. I think it's pretty simple to understand. At least I hope it is. And I think it's really cool. I mean, I think the syntax overall for everything with Minestom so far is just amazing. Even something as simple as creating blocks is so awesome. Just by being able to do block dot and then whatever block you want, you just, type it. It's just so simple, so easy. And then for the position here, this is expecting either an XYZ or you can do a point. A point is implemented by two different, well, not just two, but the two main implementations of this is the vector. So for example, var test vector is equal to, and we can do new vector vec. You can see that this accepts a x, a z, or just a single value, or an xyz. So we could put whatever coordinates inside of here that we want, like 1, 2, 3, for example, and then we could do test vector dot. And now you can do different stuff with that vector. You can add to it. You can do the absolute value, division. You can get the angle. So you can do a bunch of math operations on here, which is pretty cool. You can get it as a position. And a position is represented by POS, position, and that's the other implementation of the points interface that we have that is expecting here. So points is either a vector or a position. So we could do var test POS for position is equal to new POS. And this is expecting something very similar, which is an XYZ, but a position also includes a yaw and a pitch. A yaw and a pitch is just basically the angle in which something is located. It's hard to explain, but as an example, the XYZ just controls the coordinate of a block or a player entity or something like that. But the yaw and the pitch can control, for example, like where a player is looking or something like that, the angle in which that entity is facing, okay? Yeah, so you're going to see both of these used in different places. For example, the event itself, so event.getBlockPosition. This returns a block vector, which is just a implementation of vector that we have here. So you're going to see a lot of different variations of this, but these all inherit from point. So this means that you can pass any of these into a method like this that accepts a point. That's why we're able to do event.getBlockPosition, even though that's not a point, of course, but any of these other variations work too, okay? Anyways, that's pretty much it for this episode, everybody. That's how you can work with blocks in Minestom. Hopefully you guys learned a lot in this episode. I think probably the most valuable part is the properties, because knowing how to set more advanced block properties that are not there by default is a pretty useful thing to know. And the handlers are also pretty cool as well. So with that said, hopefully you guys enjoyed this video. Thanks for watching, everybody, and I will see you guys next time. Hey, what's up, guys? Welcome back to another video in the Minestom Minecraft server development series. In this video, I'm going to teach you guys about items. So this should hopefully be a short video because items are not too complex to figure out. What we're going to be doing here is making a new command. We're going to call this the weapon command. And this will be just used as a simple command to give ourselves an item. And we're going to learn how to actually do that, how to create items. So we're going to create a constructor. Let's remove all this. And we're going to give the command a name. So we'll just call this weapon. Let's start by creating a default executor and implement it. So we're going to say if the sender is an instance of a player. We need a player because we cannot give items to just any command sender. They have to be specifically a player. So we're going to make sure that the person who runs the command is a player. If they are not a player, then we're just going to send them a message saying, you must be a player to run this command. So an item stack is simply a way of representing an item in Minecraft. So if we want to do item stack sword, we can create a new item stack by doing item stack dot, and you have all these different options here. Of is the most simple version of this. So if you do of, you can provide a material. Same way we have for blocks. A block can be made if you specify the material, which is just what type of block it is. So same thing for items. Every block and every item in the game has a material backing it. So whenever you create a new item stack, you need to specify the material that the item will represent. So if we want a diamond sword, for example, we can do material dot diamond sword. That easy. And if you want to, you can also specify an amount when you're doing an item. So you could say 3 or 1. 1 is the default, so you don't need to put 1 if you don't want to, but that's how you can specify the amount of an item. And that's the most basic bare bones way to create an item. So now that we have our item stack, we can add it to the player's inventory by doing player.get inventory.add item stack, and then pass in the sword. And then we'll just send the player message saying a weapon has been added to your inventory. Before we learn how to customize this item even more, let's go ahead and register this command and test it out so we can make sure that this works. So we're going to do Minecraft server.getCommandManager.register new weapon command. That's all we got to do. So now let's start up the server and join it and see if this works. All right, back on the server now. So I'm going to do /weapon. And boom, I've been given a diamond sword. So it's really that simple. I can do whatever I want with this now. You know, I could kill stuff. There's nothing to kill, but I could theoretically. But yeah, you can do this with any material in the game. So literally anything that you have in here, you can get an item stack for it, which is pretty awesome. But most of the time, you're going to want a more complex configuration for this item here. Maybe you want to give it a name, some lore. So to do stuff like that, instead of doing .of, we can make a builder. So item stack.builder. And into the builder, pass in the material. So we're going to go ahead and let's do a diamond axe instead. So diamond axe. And then now we could do dot and make sure it ends with .build. Just like our other builders that we've done in the past, like with the component builders. .build is how you finalize it, and then it gives you the actual item stack that you can use to add to the inventory or whatever you want to do with it. So in between though, the builder and the build, you can add methods that will do different things. So for example, you have a glowing method. So you can do glowing, and this will make it so that the item glows. Pretty self-explanatory there. You could set lore, I'll show you that in a second. You can set custom model data, hide extra tooltips, the max stack size. You can set a custom name for the item. You can change the material again. So all kinds of stuff here that you can use to customize the configuration for this item. So let's try doing the custom name. And for this custom name is expecting something called a component, which we learned about 2 episodes ago with the adventure library. And so since we already know about components now, we can do component.text, and now we can put whatever you want. We could say magic sword. And then we could add some color to that if we want to. We could do named text color dot, we'll do dark aqua, and then we can set a decoration of text decoration italic. So I'm sure you can imagine what that will look like, but we'll see that in just a second here. You can, you could try and format this the best way you can if you want to, or what you could do is just cut the entire thing and make it a separate little variable, so it's just a little more easier to read. So we could say sword name, for example, something like that, and then you could just pass it in. And we could also do something else. Let's do one more thing. We'll set the amount for the item. So we'll set 2. And yeah, let's just take a look at what this looks like. So now we should have a sword that is or actually a diamond axe item, right? It's going to be glowing, whatever that means. It's going to have a custom name of magic sword that should be purple and italic or dark aqua. And then it should give us 2 of them. So let's take a look at what that looks like. Okay, back on the server now. So I can do /weapon. And look at that, I'm given 2 of them right away, so that's good, because I specified 2. And if you hover over it, you can see that it's a magic sword. You can see that it has the dark aqua display name and also the italic text decoration, so that's working perfectly. You can also see that it is glowing, so it's like an enchantment sort of glow, so that's what that does. So yeah, as you can see, it's pretty easy to make these items and give it configuration just using the item builder. It looks like it gave the axes in 2 different slots because, as you would expect, you can't really hold 2 swords at once. So I just want to test out something real quick. I actually haven't tried this yet. You can see that we can do the max stack size. So I would imagine that this controls how many of them can be in one stack. And for a sword or an axe or something like that, it can't be. It's just 1 probably because, as you can see, it placed into 2 slots. So I wonder if I set this to 3, this should hopefully allow us to have 2 diamond axes in 1 stack. So let's try this out. And look at that. So now we have 2 axes in 1 stack, which is pretty cool. So we learned how to do a custom name. We know how to do the amount, the max stack size. Another very useful thing is the lore of the item. The lore is just the text that shows up below the item name. So in this case, the lore, it has some extra lore like win in main hand and the attack damage and all that stuff, but you can get other text to show up under the name. So this is asking for a list of components or an array of components as var args, and each of these components here will be a single line. So for example, I can do component.text. We could say line 1 and then component.text. This would be line 2. So that's how that would appear under the item. So let's just take a look at what that looks like. Okay, I'm back. There we go. So that's how that looks like. The default styling for that is a purple and italics sort of look. You can override that, of course, because we're using text components. So you can just set the color manually or set the decoration manually and override that. But yeah, that's what lore looks like. So for example, so I'm sure you've seen that on servers. If you ever played on any sort of server where they have, custom stuff on it, you can imagine that you're given an item that, does something special, and the lore allows you to set a description for that item so that you know what it does. So that's why a lore is very useful. So I could, say something that describes what this axe does. I keep saying sword, but this acts as magic powers. You could literally put whatever you want and add some color to that if you want to. So, named text color dot gold, literally whatever you want. So that is what that looks like. Pretty cool in my opinion. Something else that I'll note here is that these item stacks are immutable, meaning that once you create one of these things, they cannot be changed. That's what immutable means. So once I have this built sword item stack as a variable, I cannot do anything with it. You have all these methods here that will get you information about the item stack, like the material, the amount, and other stuff like that. But these other methods, like width, for example, like with amount, this doesn't allow you to change the amount of the current item stack. This will give you a copy of the current item stack with the new amount. So for example, if I was to do with amount of the sword, this would be like sword 2, for example. So sword.withAmount 3, this would give me 3 of those swords, and just copy the entire item stack into this new variable here. The reason it copies it is because, again, it's immutable, because you cannot change the original one. And as the documentation says, having it being immutable, like the other things in this library, allows you to have something called thread safety, which means that you cannot change the same object from multiple threads. So for example, this is a little more of an advanced topic. We haven't really got to this, but in the future, if you have multiple threads that work with the sword here, if they try modifying it at the same time, you could get really weird results. So having them be immutable where you cannot change it once it's built gives that benefit of not having weird, stuff happen. It also says the ability to reuse the item stack in multiple places. So for example, if all your players start with the same set of items, you can just store those items as constants and add them to each player's inventory to avoid a lot of allocation. So all that means is that, for example, if I want to make it so that every time a player joins the server, I give them these items here, I could just store these item stacks as constants or just variables, at the top here, and just reuse them as much as I want. I don't have to reinstantiate them and change them, every single time and all that stuff. So with all that said, being immutable gives us benefits, but also just means for us as people who program that you cannot change the variable once you create it, okay? And again, that's why we have these with methods here, but it will not, modify the original one. It will give you a new one, a copy. So if I was to do with material, it would give me the original thing, but with a different material of whatever you specify as a copy. One more thing I want to teach you guys about whenever you're creating these item stacks here is that there's also a method called set. And this one's a little different. This one expects something called a data component. And data components in Minecraft allow you to control different properties about items and also things like entities. Similar to how we did it with blocks. Blocks, you have the block properties for the block state. We can do something very similar with items as well. So all we need to do is do item component dot, and you have all these different options here, like the base color, bees, like can break. Some of these are pretty self-explanatory, like can break makes sense if you can break it or not. Fireworks, that doesn't, I don't really know what that does, but rarity, recipes, tool, trim. I'll show you guys how to find what these mean in a second here, but for example, we have stuff like the custom name. So custom name, this is how you can set a name as well. So after you specify the item component property that you're trying to set, it also wants you to specify the value for that usually, right? But since we specify that it's a custom name, for a custom name, it wants a component. So it filled that in for us. So now it's asking for a component as the value. So we could do something like, so we could literally just use this text component up here. So sword name, and that's how that would work, okay? And so you may be wondering, what's the difference between this one and this one? We use custom name, and it's really just, this makes it easier, right? If you just have a dedicated method for setting the custom name of an item when you're building it, that is easier than doing set, specifying the property, and then providing it. So this method here does the exact same thing as this one here, it just makes it easier. So of course it doesn't make sense to have this one because we already have this one above. And there's a little trick, if you hold control and click into this will show you the implementation of the method, which as you can see does the exact same thing that we just did. It sets a item component custom name and then expects a component and passes it in. So if we just do Control Z to bring that back here, again the question is, how do you know like what these different things do and what the options are besides just doing dot and just looking at them? And just like before, we have documentation for that. So I'll have a link for this in the description below, but this is the data component documentation. And if you just read into it, data components, or simply components, are structured data used to define and store various properties. They're used on items, where they are referred to as item components or item stack components, and also block entities, partially replacing MBT format. You can see that we have a list of component section, and this gives you all the different components that you can put on these items that we're creating. You can also look at the top here on the right. It shows a full list of them that you can click into. So for example, we can click on hide tooltip, and this will tell you exactly what it does. So if set, it will completely hide this item's tooltip, including its name. You have food, which is a way more complex one. So the food stats for this consumable item. So as you can imagine, if you have a food item, you can customize the food stats for that using that data component. You have a dyed color. This is useful for a leather armor piece. You can see that we have the custom name here again, which is what we set before. So hopefully that helps you out. That's very cool, honestly. So we could set, let's just try doing the hide one. So hide tooltip. And if we do Control P, this is asking for a unit, but you can pretty much ignore this one. This one does not want any value, so you don't need to specify true or false for this one. If you just have the data component on this item, it will automatically hide it. You don't need to say like true or something like that, okay? Let's take a look at what this looks like. Okay, we're back in the server, so we can do /weapon, and look, now when we hover over the item, we don't have any tooltips at all. So, and you can add as many as you want. So you can do item component like damage, for example, and set the amount of damage on the item. And if you read into that, this is basically the this controls the durability of the item, not the actual damage that the item does. So you could say like it has 500 damage, and this will, affect the damage bar on the item, okay, for the durability. You also have something like jukebox playable. This one's really cool if you read into it. This will allow you to make the item jukebox playable, meaning that whenever you put it into a jukebox, it plays a specific CD, or rather song rather. So if you do Control P to reload this, it's asking for now a jukebox playable type. And if you just explore this, you can do new jukebox playable, and now it's expecting a jukebox song, and you can do jukebox song, it's an enum dot. You have all these different jukebox songs that you can play. So you can do, cat, for example. And so theoretically, I haven't really tested this out because jukeboxes are not implemented. But theoretically, if you put this item into a jukebox, it should be able to play the cat song. So I haven't really tested that out, but if you want to try it, then go ahead. I'll just show you that it doesn't break the server by reloading real quick and joining /weapon, and boom. So it doesn't show anything, but theoretically, like I said, if you put into a jukebox, it should be able to play that cat song, okay? But anyways, guys, that's pretty much it for this episode. This is how you can create item stacks using Minestom. Just like everything else, they make it really easy. And items are a big part of Minecraft servers, so now you should be able to add some even cooler stuff to your Minecraft server implementations and configure a bunch of cool stuff as well. So hopefully you guys learned a lot in this episode, and I will see you guys next time. Hey, what's up guys? Welcome back to another video in the Minestom Minecraft server development series. In this video, I'm going to teach you guys about inventories. Alright, so hopefully you guys know what an inventory is. It's just, what the player uses to store items and stuff like that, including their armor. But there's also other inventories like chest inventories, the ender chest, anything where like you open a window and you have items inside of it, like an anvil, for example, a horse, all kinds of stuff like that. Enchanting tables, those are all considered inventories. And what we can do is actually create custom inventories within Minestom and display them to a player. And then we can have the player do whatever, they want with them, such as storing items, or probably the most common thing that you can do with an inventory, which is really cool, is use them as GUIs, graphical user interfaces. And basically all that means is that you can use an inventory as a menu. So you show a bunch of items in the inventory, and those can represent buttons. And whenever a player clicks on one of those buttons, a specific thing happens. Maybe they're taken to another inventory, or maybe the player poops themselves, something like that, right? So knowing how to create these custom inventories and work with them is very important. To test this out, we're going to make a new command called the vault command. And all this command is going to do is whenever you type /vault, it's just going to open up a small little inventory that the player can use to store items. This will allow us to learn and test how you're supposed to make, new inventories. All right, so to create an inventory, we can do var inventory or specify the type, which is inventory if you want to. And then we could do new inventory. So you can do inventory type, and this is an enum. So inventory type dot. You have all these options here. Some of these you're probably going to recognize, like a beacon, an anvil, cartography, blast furnace, brewing stand. But then you also have these other ones like chest 1 row, chest 2 row, chest 6 row. This is just a standard chest inventory, which is 9 slots across. But you can basically choose how many rows you want to appear. So if you just want a small little inventory with 9 slots for the inventory, you can do the chest 1 row. If you want 54 slots, which is 6 rows, you can do chest 6 row, which I believe is the biggest inventory that you can have. You can even do a crafting table, so crafter 3x3. There's also crafting, I don't really know the difference, but the point is that you can choose all these different types here, even things that you don't really normally consider to be an inventory, and you can use these to represent, things like graphical user interfaces like I told you about before, which is pretty cool. Let's start just by doing the window 3x3 one just for fun. So that's the inventory type, but now you can specify the inventory title, which is the text that appears above the inventory inside the window. So for this, you can specify a string, or you can do a text component, which we learned about. So if we want to have like coloring and stuff like that, we can do a text component, and we could say something like item vault. And let's just actually take this and move it into a variable. So say inventory name is equal to component.text, and then we'll add some color to that. and we'll make it named text color gold, and then we'll make it bold as well. So text decoration bold. There we go. And I will pass that in. So inventory name like that. So now we've created this new inventory. And with this variable, you can do different stuff like making it so that someone is a viewer, change who's holding it. You can add an item stack. You can update the title of the inventory. Probably the most popular one is going to be adding item stacks because the whole point of inventories is to hold items. And like I said, if you use them as a GUI, then you want options in those inventories. So adding these item stacks is, very important to be able to do. Other than calling methods upon this inventory object, what you can also do is make it so that it opens for a specific player. In this case, it'd be the person who ran the command. So let's make sure that it is an actual player first, because you cannot open an inventory for the console, for example. So sender instance of player. Make sure you import player from Minestom. So if it's a player, then we can go ahead and do player dot open inventory, and then just pass in an inventory. So inventory, just like that. We'll send them a message as well saying opened inventory. And that's it. So to create an inventory, you just simply do new inventory, tell it the type, tell it the name, and then you can open the inventory for a player by doing player.open inventory. Very, very easy. Let's go ahead and register this command and try it out. Okay, we're on the server now. So to test this out, we can do /vault. And look at that. We got our item vault. We got our gold text, which looks extremely ugly, but it's there. You can see that you can provide that custom title, which is really cool. But you can also see that now you have a 3x3 grid that you can use for whatever purpose you want. So if I had items in here, I could simply put them into the inventory and, move them around, all kinds of stuff like that. Just like you would expect with a normal inventory, which is below. This is the player inventory down here. So technically we have two different inventories open, the player inventory and our custom inventory that we just created. Now that we know how to create inventories and open them for players, which is the most important thing that you could do with an inventory, now I want to show you guys how you can handle inventory events. If you come from other frameworks like maybe Bucket, the way that you would handle inventory events is by, making a listener for it, and then you have to somehow figure out which inventory that is referencing. Luckily, within Minestom, they make it pretty easy because they have event nodes that are able to filter out different things based on conditions. So let me give you an example here. This was taken from the documentation. So after we create this inventory, what we can do is create a new event node. We'll call it the vault node, or say vault inventory node, is equal to event node dot type. And if you don't remember how this works, then go back to my event listeners episode, and then we're just going to give it a name. We're going to call it the vault inventory. And now it wants a events filter, which we can provide by doing events filter dot inventory. And what this will give you is a event node that can only have listeners that are related to inventories, which alone is awesome. But what we can also do is add a predicate to this. And so we'll expand the lambda here. And what this will do is give you access to the event and also the inventory. So we can do inventory 1 is equal to inventory. So what this will do is return true, return false. So what this will actually do is make it so that this will be an events node specifically for this inventory that we just created, because we're adding a predicate here that only returns true when the inventory involved matches this current inventory that we created. So basically what that means is that we're creating a event node specifically for this inventory alone. And that means that any listeners that we add to this node here all will be only for this inventory, which is pretty cool. And I don't want to understate the benefit of this. Basically, like I said before, with other frameworks like Bucket, you would have to, add a listener and then somehow figure out if that, inventory involved matches the current inventory that you want to handle. In this case, since we have an event node for a specific inventory, we don't have to worry about that at all. It literally matches to the exact inventory, which is awesome. Let's try adding a listener to this. So we can do vault inventory node dot add a listener. And now it wants the event that we want to listen to, so you can just start typing inventory, and this gives you pretty much a list of all the different inventory related events that we can listen to. So the pre-click event, the close event, the click event, pre-click event, item change event. That's pretty much it. I think those are the major ones. Inventory open, inventory close. So let's just try the inventory click event. That's probably the most popular one, or pre-click. And so now every time, we run some code, whenever this inventory is clicked, it will only happen for this inventory, of course, because, the node is filtered to that specific inventory. Let's just make this pretty simple. So we're just going to make it so that whenever this inventory is clicked, we're going to send the person who clicked it a message saying, you clicked the inventory. Something interesting is that when you do events, you have access to the information about the event, like the player, the clicked item, the inventory itself, the click type, the slot, and the cursor item. For the click type, this is going to be an enum, like, for example, click type. And you have all these different types of clicks. So you have left click, change held, double click, drop, right click. So you can have really fine-grained control over how you want things to happen whenever someone clicks your inventory in a certain way. So you could have it basically distinguish between a left click and a right click. So if they left click a specific item, something happens, but if they right click that same item, something different can happen, which is really cool. But another thing that you have access to is the slot. So the slot is basically the slot in the inventory where the click happened. So I'll explain that in a second. Let's just start by printing these out so we have an idea of what slots we're clicking on. So we'll do event.getPlayer.sendMessage, event.getSlot. And this is returning an int, so it's kind of complaining about that. So I'll just wrap it with a string like that. And one other thing that we can print out just to show as much information as possible is the material of the item that was clicked. So we can do event.getClickedItem. This is very important because you want to handle stuff differently depending on which item they click. So getClickedItem.material and then .name, which will print out the material name. So what we have done here is added a click event to our inventory event node that is only for this specific inventory here. And so whenever this inventory is clicked, it will run this code here. You can add as many listeners as you want, and they will all just be for this specific inventory, which is, again, really cool in my opinion. So one thing that we need to do before we can actually test this out is add our event node to the global event handler, because if we just create this and don't use it anywhere, nothing's going to happen. We're just creating it for no reason. So we can do that, I'm sure, a bunch of different ways, but an easy way is just to do Minecraft server.get global event handler.add child, and we could add the vault inventory node that we created before. So now not only will the node be added to our global event handler, but so will the listeners added to that node as well, and other children. So let's try this out. Okay, back in the server, so we can do /vault, and here's our custom inventory here. So if we click an item, boom, it says you click the inventory, 0 for the slot number, and then Minecraft error is the type. That's something that I should mention. So whenever you have an inventory, slot that is empty, that is not going to be like null or something like that. The material for that is going to be error, okay? So that's just important to know. As you see, when I click around, it's printing out all this information here. You can see that the slot numbers are changing. And basically the way it works is kind of self-explanatory. It's top to bottom, so top left to bottom right. So 0, 1, 2, 3, 4, 5, 6, 7, 8. Something that you have to remember though is that it's 0 based. So the first slot is not going to be 1, it's going to be 0. So 0, 1, 2. Hopefully this is all helpful so far and interesting. It's pretty easy to be able to create these inventories and display them to the user. Anyways, another thing that I'll note here is that whenever you close this inventory after opening it for the player, the inventory is gone. If you want everything inside the inventory to be saved and you want to reopen it for the player at some point, you just need to move this into some place where it's like not going to be deleted once they run this, because right now, since this is a local variable inside of this set default executor method here, it will obviously not exist anymore after the player closes it, because it no longer is part of any scope or whatever, okay? But what I want to do is actually make another command here so that we can get some more practice working with these inventories. We're going to call this one the menu command, just so that I can show you guys an actual example of creating a GUI menu. So, and just like before, basically if the person who ran this command is a player, then what I want to do is open an inventory for that player, but give them a bunch of options that they can click on. Yet again, let's open an inventory. So var inventory is equal to new inventory. We're going to do the inventory type, and we can choose one that sort of fits what we're trying to do here. We just want to have a small GUI menu, so I'm just going to go ahead and do chest 1 row, which should just be 9 slots in a single row, kind of like a chest. And then we'll give it a name. We'll call it menu. And now at this point, since we have created it, it's just going to be an empty inventory. So we need to actually add items to it. So we can do that from what we learned from last episode. So we can have different items like var fart is equal to item stack dot builder. We can pass in the material for that. So material.dirt. And then we can give it a custom name like component.text fart. Color, we can do text color dot, let's just do color. And what we can do is just give it a random color and then use this little tool here to customize that color, which is pretty useful. Set it to some kind of, orange brown color. So that's the color for the text, and we'll add a text decoration of, let's do bold. So text color or text decoration bold. Okay, here's 2 more items for feed and kill. So for feed, it's going to be a bread, it's going to say feed in bold. For kill, it's going to be a diamond sword, it's going to say kill in bold. Okay, so these items here can represent the buttons for our inventory. So to add them to our inventory, we can do inventory that add item stack. And what this will do is if you just pass in an item stack, it's just going to add it to the first available slot. Or if you want to, you can do set item stack like that. And then for this one, you can provide a slot number, a specific slot number, and the actual item stack that you want to add. We know that 0 is going to be the first slot, so we can do 0 and then fart if you want it to be like that. And then we can do inventory.set item stack 4. and feed, and we can do inventory dot set item stack 7 or 8 rather, and kill. And I'll show you guys what that looks like in just a second here, okay? So just to recap, we're creating this inventory, we're creating the items that are going to be displayed in the inventory, and then actually adding them to the inventory in specific slots. And then now what we can do is do player.open inventory and then pass it in. So now it should be displayed to the player at that point in time. Okay, we're back on the server, so we can do /menu. And look at that, here's our menu, our custom menu that we've created. We can see our fart item, our feed item, and our kill item. So it looks awesome, right? So you can move them around as much as you want. You know, probably don't want this if you're having like a menu, for example, though, but I'll show you guys how to cancel that. You can move them around. You can move them into your personal inventory if you want to. You can close it, reopen it. What that is going to do is create a new inventory, because we're creating a new inventory every single time we run the command. But, we can steal some more items if you want to, LOL. The next step here will be to add listeners for this one in the same way that we did for the previous one, so that when you click on these different buttons here, stuff actually happens. What I think we should do is separate this code here into a separate method, just so that it's a little more structured. So we'll take all of that, and then we'll go down here and do private inventory create inventory. And then we'll have it return the inventory that is created. We'll do var inventory is equal to new inventory. There we go. So now we can go back up here and do var inventory is equal to create inventory, just like that. So let's go ahead and add that event node now. So we'll do menu inventory node is equal to event node dot type. And this is going to be called the menu inventory, something like that. Just menu inventory is probably good. And then we'll do event filter inventory. So it's specifically for inventory events. And then now we'll add our condition here so that it only does the inventory that we currently have. So inventory 1 is equal to inventory, just like that. And then we could simplify this by doing alt enter, replace with lambda, and you can move that into a new line if that's easier to read. And so now that we have this event node here, what we can do is add a listener to it, or whatever listeners that we want to have. In Minestom, you have two events for the click event. You have the inventory click event itself, but then you also have the inventory pre-click event class. It's not exactly clear to me which one you should use at all times, but the Java docs do give you a little bit of information here. So if you do Control Q on the inventory click event, it says called after the inventory pre-click event, which makes sense. This event cannot be canceled, and items related to the click are already moved. So for the pre-click event, it says called before inventory click event, used to potentially cancel the click. So all I know is that the pre-click event is useful when you want to potentially cancel the click from going through. So if that's something that you want to do, then you should probably listen to that one. But for the inventory click event, you can still get the items that were clicked, for example, but you just can't cancel the event. So the documentation also says the inventory pre-click event allows modification of the raw information about the click, such as the click slots, the click type, which button was used, etc. And this occurs before the click is processed. And then the inventory click event allows modification of the slot changes and side effects that occur as the result of the click via event.getChanges instead of just the click info. So my understanding is that for the inventory pre-click event, that is useful if you want to modify the click itself, like canceling the entire event, or change the click type or the button or anything like that. But the inventory click event is kind of sort of as if the click already happened and you just want to process what happens after that has occurred. With that said, I'm going to go ahead and do the inventory pre-click event, and then I'm going to add a lambda for that and change this to event. And the reason why we want to cancel something like the inventory click event using the pre-click event listener is because when we do set cancel to cancel it, this will prevent the user of the inventory from moving items around. So anytime you want to have something like a GUI where you just want them to click on items and not move the items around, then canceling the pre-click event will allow you to have that, functionality, okay? Besides that, you can also get information about the event, just like the click event. You can get the clicked item, the click type, so we saw that before, the slot, same as before. But since it's the pre-click event, you can modify the clicked item and also the cursor item if you want to. So we can do something like var clicked item is equal to event.getClickedItem, and then we could say if clicked item is equal to fart, for example. I guess fart isn't within the scope here, so what we can do is either make fart a variable of the entire class that exists for every single, running of this command here, or we can just take this and move it inside the creation of the inventory, which I'll do that for this simple example here. So I'll just move it down here, and so now fart is just this variable that we have above, which is the inventory item. And so if a fart happens, we'll just do event.getPlayer.sendMessage, you farted, clicked item is equal to food, what is it, feed, And we could add stuff for that as well. All right, so hopefully you understand what's happening here. Basically, it's going to listen for the inventory pre-click event. As we know, this will automatically match to the current inventory, which is the menu inventory. So we know that we can just go ahead and cancel it without checking anything since we know it's that inventory, which will make it so that you cannot move any items in this inventory since it's just a menu, right? And then we're also getting the clicked item. So the item that was clicked, we're getting it the actual item stack of it. If you do Control Q, it tells you the return type. So this is the item stack of the item that was clicked. And we're checking to see if it's equal to our fart item stack, if it's equal to our feed item stack, or our kill item stack. If it's equal to any of those, we're going to run different code depending on which one was selected, okay? This is a very simple way of handling inventory clicks. And let's not forget, we need to add this event node to our global event handler, just like that. Okay, back in the server now, so we'll do /menu. We can go ahead and click these now, and it says you farted. If I click error, nothing happens because it's not matching to any of those else if statements. And look at that. So it's able to distinguish between the different items. And also you'll notice that whenever I open the menu, you cannot move any of these items around because we are canceling the inventory pre-click event. So it's going to prevent it from going through essentially. Pretty freaking cool. And I just want to reiterate, you have a lot of control over these events here. So, for example, we can get the click type again, right? We could say if inventory get click type is equal to click type dot left click. Let's say that we only want all of this code to run for left click and not for right click, right? We could even have it only be canceled for left click, but if they want to move the items around, they can right click or, do some other type of click. We can have that, right? So let's try that out. So now if I left click, it's still going to work the same as before, but if I right click, now I can move these items around and it won't prevent me or print any of those messages because the rest of that code is not being ran because it doesn't pass the condition, obviously. I can even shift click if I want to. So you could do it like this if you want to. You could also do like an early return. So if it's not equal, you could, maybe return like that and then run the code. You could also, we learned about before the events listener builder. So if we just take all of this code here, delete this part, get rid of this part, and do events listener.builder, we can tell it the class that we're trying to listen to, which is the inventory pre-click event.class, and then we can build onto that. So we can do build, and then we can add a handler, which is going to be all of this code like that. We'll rename this to events. And then what we could also do is add a filter. So the filter, instead of having that if statement that we had before, that would be in one of the filters. So we can add as many filters as we want, but we could say something like return inventory pre-click events dot get click type is equal to click type left click. So this will make it so that this listener here only runs for inventory click events that are using the left click, okay? One more thing I want to show you guys is there's something cool that you can do. Again, there's a lot of different listeners you can do, right? Just besides the click listener and the pre-click listener, you can also do something like the inventory close listener, or rather events, inventory close event listener. So like that. And what you can do is, since this listener is only tied to this specific inventory, whenever someone closes the inventory after being opened, it's obviously going to trigger the inventory close event. So this will listen to it. And then what you could do is actually have it delete the node. So you can get the global event handler and you can do remove child. So remove child, menu inventory node. So down here, we're adding it at the end of this, method here. But once the listener has detected that the inventory has been closed, it will automatically remove it. So we're not just having event nodes that we don't need. Anyways, that's pretty much it for this episode, guys. Hopefully you found this video interesting and now you guys know how to create inventories and how to work with them. I think it's really cool because in my servers, I like to have, graphical user interfaces, menus and stuff like that. And I think it will be useful for your servers as well. And then you can also add the listeners, which is really cool too. So hopefully you guys found all of that interesting, and I'll see you guys next time. Hey, what's up guys? Welcome back to another video in the Minestom Minecraft server development series. In this video, I'm going to teach you guys about entities. Entities are things that appear on the server for a period of time, like items that are on the ground, players, monsters, any mob, that's an entity as well. Projectiles, like when you shoot an arrow, fireballs, anything that you would spawn and then at some point could be removed. That is an entity. So what I'll be doing is making the spawn command here so that I can show you guys how to make entities yourself, how to spawn them, and also how to configure them. So every entity has the top level class entity. So entity is equal to, and then to create a new entity, you could just do new entity. And now you need to specify the entity type. So entity type dot, and you have all the different entities in the game. So you have things like animals, like mobs and stuff like that. You have, like I said before, you could do arrows, even arrow like that. Yeah, anything like that, that's an entity. So let's try doing a camel, for example. So we can do a camel. So this alone will create an entity for you, but it will not spawn it. So to spawn an entity in your world, you do entity.setInstance. set instance, and you pass it the instance as well as the location where you want to spawn it, and it will spawn it. To make it easy for us, I'm going to make it so that the entity spawns in the same location where the player ran the command. So let's go ahead and take this and check to see if the person who ran the command is a player. So once we have that, we can now do player.getInstance. And then we can also get the player's position by doing player.getPosition. And there we go. That's literally all we need to spawn a camel. We simply create a new entity object and specify the type as a camel. And then we set the instance to tell it where to spawn the entity, and it will spawn it. So now let's go and register this command so that we can actually test it out on the server. All right, I'm on the server now. So to test this out, we're going to do /spawn. And boom, there's a camel inside of me. Hey, yo. Okay, so yeah, here's the camel. He looks very cool. He's not going to really move around, or you can't really do anything with it because same as everything else with Minestom, it's not implemented. So whenever you hit it, it doesn't actually take damage. That's actually for another reason, which I'll tell you in a second. So it doesn't really move around. In a future video, though, I'll show you guys how you can work with the AI of this entity here so that you can make it actually move around and do what normal entities like to do. For example, if you spawn a zombie, you can make the zombie attack people and, stuff like that. But for now, we have spawned a camel entity, and now it exists in this world, and we could do stuff with it. So we could do entity dot, set velocity to change its movement, to make it go in a certain direction, perhaps. You have stuff like set auto viewable, which decides if the entity should be auto viewable by nearby players, which means that players can view it if it's in range. You can make it glow if you want to, so we're going to make it glow. Let's see what that looks like. And you can also set no gravity. We'll do that as well. But since it's already on the ground, let's make it so that it spawns above. So we'll do 0 to 0, which will add 2 to the Y axis. So it should spawn above where the player is by 2. Okay, back on the server now. So if I do /spawn, there we go. Now our camel has spawned in the air, and you can see that it's not falling down because there is no gravity on the server. So that's cool. And you can also see that it's glowing by the little outline that it has. So that's also pretty cool. So that's some of the basic things that you can do with an entity, but something that you can also do is configure the entity's metadata, which is very similar to how we do it with blocks and items. So if I know that this entity is a camel, all I need to do is do camel meta is equal to entity.get entity meta, and just cast that entity meta into the camel meta, like that. And so every single entity type that you have has a corresponding meta that goes along with it. So if you have a zombie, then you would get the zombie meta. If you have a arrow, you would get the arrow meta, and so on, okay? And this will allow you to edit the specific metadata or information about this specific entity type. So we can do camel meta dot, and we have stuff like get last pose change tick, is dashing, set dashing, stuff that probably pertains only to camels. I don't really know much about camels, but I think these should only be for camels. Let's change it to a zombie so I can just show you what that looks like. So we can do zombie, and then now this would be a zombie meta, like that. Now we have created a zombie and spawned it on the server, and then we're also getting the zombie meta so that we can do stuff that only pertains to zombies. So zombie meta dot, and you have stuff like setting it to baby, so like a baby zombie, for example, so you can do true. Also, I think it makes sense to configure most of the stuff before you even spawn it, because you shouldn't change it to a baby after you've already spawned the zombie, right? So set it to baby true, and then you could do, literally whatever else. You can set a custom name if you want to, so set custom name. This is expecting a component, so component we already know about, component.text, and we could say zombie, grandpa or something like that. We can even give it a color. But to actually make that name appear, we can do zombie meta.set custom name visible and just pass in true. So that will make it actually appear. Let's take a look at what that looks like. All right, back in the server, so now we'll do /spawn, and boom, look, there's our zombie grandpa. It is a baby zombie, as you can see. It has our custom name, which is cool. We can set that to whatever we want using the text components that we learned about. It's glowing still. So these entities that you spawn are really customizable, which is awesome, using not only the methods available on the entity class itself, but also on the metadata for the entity. You get a lot more information that you can customize. Now, I told you before that entity is the top level class for all entities, but there's also subclasses of that implement entities, like a living entity. This is just an entity that has life, I guess you could say. It has a health, and also it's able to die. Of course, this is not implemented by all entity types. This is only going to be for certain things like zombies or stuff that just kind of makes sense for a living entity. And then there's also another one called entity creature, which enables pathfinding and AI and all that stuff, so it can move around. But if you make this a living entity and you change the type here to a living entity, what you can do is actually access more methods upon this, like entity.set, and now you have other options like set helmet or set health that were not previously available. So I could set the health of the zombie, I could set the helmet. So the helmet's expecting a item stack. We already know how to do item stack, so we'll do item stack.of, and we could do material gold. Let's try let's see if it lets us do a gold apple. I don't know what that will look like. I don't think that would even work, but let's just try that out. Okay, back on the server, slash spawn, and wow, look at that. We have spawned a zombie with a golden apple on top. That looks really weird. I had no idea that was even possible. That's really cool. But yeah, there's living entities, there's entity creatures. You also have projectiles like entity projectile. That's another subclass for specifically for projectiles like arrows and stuff like that. I'm not going to really go into each of these in this one episode, but as we, progress through the series, we're going to explore some of these different subclasses probably and check those out to accomplish different things. But I think you guys understand the gist of what you need to know to be able to spawn entities and configure them, which is really cool. I found a piece of code that I just want to copy and paste so that I can show you guys that you can make your zombie move around if you want to. So I can just change the name of this to entity. And currently it's a living entity, not an entity creature, right? So it doesn't have AI capabilities, so we'll change it to that type, entity creature. And a zombie can be entity creature, so that's going to be fine. If you try making a new entity creature out of like a boat or something like that, like the documentation suggests, you will get an exception. It will crash the server for the player, I believe. Like it just doesn't work for some reason, which is interesting. But yeah, it kind of makes sense because how can a boat be a creature anyway? Anyway, so I'm going to take this and pass it in everywhere here. I'll have a separate video on, how to do all of this, of course, so don't worry about that. So what this should do is basically after it spawns the zombie, it should add an AI group. So it's saying it should attack, and then it's also going to choose the closest entity target, which is a player. So if there's a player around the zombie, it's going to chase it essentially and try and attack it. All right, let's try it out. So spawn. Now look at that. He is chasing me now with his stupid little golden apple head. So he will chase me until forever, basically. That's just an example of how you can do something like that. We'll explore that more in the future. Something else that I found out, which is really cool, is that entities themselves have event nodes directly on them. So I can do entity dot event node, and you have an event node specifically for this entity already created, and it's filtered specifically for entity events as well. So with this, I can do stuff like, add listener. I don't have to create my event node myself. I can add the listener, and then now I just need the event type that I want to listen to. So this would be an entity event. And these are all the different examples of entity related events. And this event node here will be only matching to events that target this specific entity, right? So if I do, for example, the entity spawn event, and this entity is not the one that spawns, it won't be triggered obviously in this listener here. It will only trigger this specific listener if this is the entity involved in the event, okay? So I can do entity spawn event. I can make a lambda out of that. And then now I can make some code. And I could say something like, let's say player.getInstance .send message, the grandpa zombie has spawned, something like that. I don't think that's going to work because it expects a component. So let me take that component .text like that. Okay. There we go. So now we're sending a message to the entire instance, so everybody in the instance, that the grandpa zombie has spawned whenever it does spawn. So whenever it triggers the entity spawn event, we're adding the listener before we're doing the spawning, which makes sense because if we add it after, then the entity is going to spawn before this is even registered, so it won't trigger the event listener, okay? So we can add another one, or as many as you want. So we could do, for example, the entity death event as well, because this is a living entity or entity creature, which is also an extension of living entity. It has the capability of having health and also dying, so this could happen. So if the entity ever dies, this will be triggered. So we could say the grandpa zombie has been killed, for example. And now since the event node is already part of this entity and we don't have to worry about it, it's already created for us, we don't have to add this event node to the global event handler or as a child of something else. So that's pretty cool as well. You can just directly create these listeners for the entity specifically. Okay, slash spawn. All right, it says the grandpa zombie has spawned, as you can see in the chat below. So that event listener does work, as you can see. If we do the player entity interact event, listening to this specific event on this event node will not work because the event node is filtered to only entity events, but it's also filtered using a predicate to only match to events that have a entity that matches this current entity. So what I mean is that if you do event.get, you have get target, which matches to that entity if you interact with it, but the predicate is trying to match to get event, and that's just not going to work. That's not even available. So for example, if I go to the one above, I can do event.get entity, and this matches to our zombie entity in the event node, but this one doesn't have it, so it just doesn't work. So I know that's a little confusing. I probably didn't explain that good enough, but the point is that certain entity events, like this one, for example, do not work, and that's why. It's because it doesn't match to that entity specifically. And it also just might be because it's a player related event as well, a player entity interact event, not just a entity event on its own. So that's also a possibility. So if we really wanted to listen to that event, what we could do is make a event node and also just add it to the global event handler like we did in the last episode with the inventories. So we could do var entity node is equal to event node dot type, and we could say entity node, and we could do an event filter of only entities, or rather entity related events, and then we could do entity node dot add listener, and now we could do the player entity interact event. And the reason I'm even showing you this is because I want to show you guys how you can detect whenever you right click an entity or hit an entity. This is the event that would be triggered by that. So what you could do is do events.get, and we could get the entity that was hit. This would be our zombie in this case. We could get the player who actually hit the zombie, or not even just hit them, also right click them. Get the instance that it happened in, get the hand that was used. So this could be the main hand or the offhand. You can also get the position at which it happened as well, okay? So to demonstrate this, I'll just print out a message, or rather we'll send the player a message. So events.getPlayer.send message, you interacted with the grandpa zombie. And we're also going to print out the hand that was used as well, because I just want to show you guys what happens. And last but not least, we need to add this events node to our global event handler. So add a child entity node, just like that. All right, so here's the zombie, and if I right click it, we get main, you interacted with the grandpa zombie, and then off, you interacted with the grandpa zombie. So even though I right clicked it using this, I guess that's my main hand that's showing right now, it still triggered both the main hand and the offhand. So the listener is going to be hit twice. So you just want to make sure that you filter for only one specific hand that you want to handle. So what I'll do is just add some code to this saying if the events.getHand is not equal to hand.main, then if it's not equal to that, then we're just going to return so it doesn't run any of the code after that. That way it only runs for the main hand. Let's also make sure that this listener only runs for the actual grandpa zombie itself, the one that we just spawned, because currently we have the player entity interact event, so this will be triggered for every single entity that the player interacts with. It's not filtered to this specific zombie entity. So to filter it, we're going to do events.get target is not equal to entity. Entity, again, is our zombie that we spawned above. In the future, we should probably give it a better name, but that's okay for now. So again, this will only run the code under it if it's using the main hand, and also the entity involved that was interacted with should be the zombie entity that we just spawned in this command. So just to test this out, let's make it so that whenever they right click or interact with this entity, it just kills it, okay? And we know that we can kill it because we spawned it as an entity creature, which is also a living entity, which is an entity with health, like I told you before, right? So if we do event.getTarget, we know that it gives us an entity, so we just need to add a piece of code here. We can do if event.getTarget is an instance of living entity, then we can go ahead and do living entity.kill. That is a method only available on living entities. That's why we had to cast it, because it doesn't make sense to kill something that is not living. So this will, as the documentation says, kills the entity, triggering the entity death event. So not only will it kill the entity, it will also trigger this entity death event that we added before, so we can test that out. However, if you don't have a living entity and you just have a normal non-living entity, you can remove it from the server by doing just remove. That will essentially bypass killing it. And also, like it says, does not trigger the entity death event because you're not killing it, you're just directly removing it from the server. So that's another option if you want to. But let's go ahead and kill it so we can see what that looks like. But if we right click it, boom, he dies. So you can see that he died. Play the little death animation. It says you interacted with the grandpa zombie has been killed. So not only did it print out the message from our interact listener, but it printed out the message from the death listener as well. So both of those are working as we expect. So there we go. That's the basics of creating entities and configuring them and adding event listeners for them and using the built-in event node for them. I just want to show you guys one more thing just for funsies. We're going to do var entity name arg. We're going to add a syntax to this command. Entity name arg is equal to argument type. And then you have all these options that we're already familiar with, but another one is entity type. We want a specific entity type, and what this will do is automatically give the player a list of entity types to choose from, which is pretty cool. So let's give it a name, entity type, and then now we'll add a syntax for that. So add syntax, add the lambda, and then add the argument, so entity name arg. So now to run this command, you have to do /spawn space and then the entity type. So first, let's just check to see if it's a player like before, because we're going to do the same code as above, which we need the player for. And then if it is a player, what we can do is get the actual entity type. So entity type is equal to context.get, and then pass in the arg. So what's cool about this is that it will give you a list of entity types to choose from when you're running the command. And then inside of the syntax here, it's automatically going to get it as an actual entity type variable, which is even cooler. It automatically does all that hard work for you, which is awesome. And so with that entity type, we're just going to do entity is equal to new entity, entity, and then we're going to pass in that entity type to create that entity. And then now we're going to spawn it by doing entity.setInstance. And just as before, we're going to spawn it in the player's location. So in player.getInstance and then player.getPosition. There we go. That's literally all we got to do. We're creating this argument here. We're creating a syntax for that argument. We're grabbing the entity type from the command that was run and then creating an entity of that type. Let's take a look at what that looks like. All right, back on the server now. So we'll do /spawn. So that's the same as before. We get our zombie grandpa here. You know, this crazy little guy. Let's kill him. There we go. He's dead. But now if we do /spawn space, we have all these different options here. So because we're using this built-in entity type for the argument, it's able to give us a list of all the entity types that it supports. So we can literally just choose whatever we want, like evoker. I don't even know what that is, to be honest with you. And there we go. That's an evoker. Cool. You can do arrow. So that spawns an arrow, and it just falls to the ground because there's gravity. You can do an axolotl. There's that crazy looking thing. So yeah, I just want to show you guys how to do something like that. I think that's pretty interesting, so that you can create commands that accept entity types, and then you could, you know, do whatever you want with that information. But yeah, that's all I got for this episode, everybody. Thank you for watching. Now you guys should know how to create entities and configure them. And yeah, so that's it for this video, everybody. I really hope you learned something new. If you liked the video, please hit the like button, and if you want to see more, hit that subscribe button. Make sure to also check the description below for important links to code and other resources, but also really important, join our Discord. We have a big community of over 5,000 programmers, and it's a place where you can find new friends or get help on any code that you're stuck on. If you want to support what I do on this channel, please consider hitting the join button below, and this will allow you to support my channel for as low as $1 a month, but there are different tiers to choose from if you want to. For anyone that becomes a member on my channel, you get a special rank on my Discord server, early access to new videos, and you can just see yourself on the screen right now. So if that sounds cool to you, feel free to join. If you don't want to, that's fine. If you can't, that's okay too. I really just appreciate you watching the video anyway. Thank you so much. And that's it. Peace.